Alrighty, hello, welcome to the stream. Sorry, it's a bit late. It's midnight. I'll be up at 10, and then I wasn't. So, and then I had to fix the code that's supposed to renaming the stream because I messed up, and although I had the code to make it refresh its token every hour, like set up, I just never actually checked to see if it needed to refresh its token. So literally after 1 hour, it lost the ability to be able to edit the code. That's fun. And it's even, ironically, it still wasn't even throwing an error because I'd even made it check to make sure that it didn't try and do it when the token was expired. Anyway, today we are making n-dimensional chess. So basically, it's just normal chess, but it's going to be able to be expanded into any number of dimensions. So, as you can see here, maybe we should skip back to 2-dimensional. So, how do I do that? Yeah. So, if we say the number of dimensions is 2, it should look like normal chess. And then start that up, and we'll have the normal chess, and then when we expand it in the 3-dimensional chess, and then we expand upwards, and then 4-dimensional chess. Come on. What's taking this long? Why are you being slow? Yeah. Oh god. Okay, so we got normal chessboard. You can pick a piece. No, obviously, I've got no logic for which piece can move when, so you can just keep moving the same piece. That's interesting. Oh yeah, because you can jump to here. No, interesting. Why can't you detect jump? Wow. Okay. Yeah. All right. Anyway, maybe black logic doesn't have the right logic. Interesting. So then we're going to go back to 3-dimensional chess. Okay. Really what I need to do is make it so you can change the number of dimensions in instead of having to recompile, because the actual code is dynamic. I'm just changing a resource, but anyway, so now I've got 3-dimensional chess, so that pieces can actually move. So obviously, because they're pawns, they can still only move in the pawn direction. Actually, should we use this one and go here? This pawn would be the one. You go here, and then you go. No, why are you not working? Okay. Yeah. See now and then you can jump down there. I don't know why you couldn't jump diagonally down to this piece. Interesting. Okay. There's still obviously a lot of bugs in my code for checking logic. And then we go to 4-dimensional. And after that we'll skip straight to 7-dimensional, which is the largest that I think I have a way of representing conveniently otherwise. The idea is that you'll be able to represent any dimension of chess by basically displaying up to 7 at a time, but you can scroll through the different dimensions. So you lock all the other dimensions to a specific one, and it's like a slice of those, similar to this would be 4-dimensional. You can see all these, and then you scroll through those, but now can actually render them all at once because 3-dimensional space. So now let's pick a piece that's going to have some interesting behavior. So we'll go this one, and we'll go if you come forward, and then you come forward, and you come forward, and we go, hey, so you can jump that piece, that piece, that piece, that piece, or you jump all the way over here because it's still technically diagonal from the perspective of that pawn. You can also jump to this piece. So 4-dimensional. It's very confusing about where a piece can go, but very intuitive in the sense that it still looks like a sequence of chessboards. And then we got up to 7. I think I said was the maximum. And 7-dimensional chess is just very silly. I had to do a lot of optimizations to make 7-dimensional chess not lag the shit out of the game because it's going to take a while to render it. It's thousands upon thousands of oh, well. I don't see the chess pieces, which means that something's gone terribly wrong. But as you can see, it's a lot of chessboards. Didn't say anything in the console. Why are there no actual chess pieces? But like, you could imagine that if you're actually playing 7-dimensional chess, like there's an awful lot of places that a piece could go when you click on a piece. So the way that the 7-dimensional is worked out, and I might need to space it a little bit better so it's easier to see the edges of the boards. But it's you have the your normal 2D, and then your 3, and then your 4, and your 5, and then between so you're 6, and then you're 7. So you have lots of chessboards, and so there'd be a lot of pawns. I don't know. I'm still not quite following. But theoretically, 5 would be the one that doesn't just tessellate the boards onto a larger scale like that. But I don't know why the pawns just. Okay, interesting. Bizarre. Right. So should we start with adding like more than just the pawns? I also need to work out why the black pawns aren't working. I'm assuming it's because I've only added the correct logic to the white pawns. I need to work out also why when I move the black pawn like here, why can't, so you can jump him. You obviously can't move because there's something directly in front of you. You can jump in. You can jump. Okay, so maybe it was just weirdly like I hadn't actually put it in the place I thought I had. Okay, so they all seem to get to it. I'm trying to think where else would a pawn... Theoretically, I think any of these pawns can reach him. Apparently you can't. Oh, because you're a board lower. You. And you? No, you can't. Can't you reach him? Okay. Because any of these can reach him. No. Wait a second. Well, it wouldn't be you, it'd be you. Can you reach him? No. No. The hell? You can reach him. You can reach him? Yeah. Must be you can reach him. Yeah, okay. Okay, anyway. Let's track down why the pawn's not working. So we go to pieces and go. So try capture diagonally. So this shouldn't be the same. I don't think. If position equals next. Continue. The next start dimension 1. Okay, end dimension is dimensions -1. Okay, and we're stepping in -1 to 1. Try 1 in every direction. Okay. So deck. Something about that says it's got to be the other way around. So you're broken because you just can't jump those. I think it's because when I do this, it's actually checking here. It's checking every dimension that away. Maybe, I don't know. Next, which is deck. No, because it should be trying 1 step in every... Okay, so some entity to get board position and but that'd be it. White. Okay. So I was checking to see if there was an enemy on the piece that you were trying to jump onto, but I was checking that the enemy was black, and it was black that I was checking for, so that should have fixed it. Okay, cool. Yay. Okay. I should probably also work on like actual like decorative pieces, but anyway. So we have a pawn. The iterates are everywhere on the board. King. I need to go like chess. I have a vague feeling that the kings are supposed to be on opposite sides. No, the kings actually do face each other. That's bizarre. I would have thought the kings would be opposed to each other, not directly opposite each other. So the kings are always in the what is that? A, B, C, D, E. The E rank, okay. So if position 0 equals 0, and so how do we make only one king spawn? Probably want to add something like position all but 0 5 0 1 2 3 4 all but 4. Okay. Yeah. Then we have to go to no piece area where we need position. So we need to find wherever I put position, which is probably we'll just find anywhere. So I can have 12 to position. We have a position here. I'm gonna say, hey, position, we need a oh god. All but that takes in self. Wow. Right. And this is just return the bool, and so we say for V and iterator enumerate, if I does not equal dim and V I equals dim, we skip that. Okay. I think the AI is actually pretty good at this kind of shit. All but one. So then we go back to our piece logic here and we go, hey, so I don't remember how this logic works. So we need to spawn in a king. And we need to say, hey, wait. King. Team white material is visible at position. Yep. And then else if position 0 equals 7 or by dimension 1. Okay, so black king material king visible. Okay. So that should let us spawn in a king, and then somewhere we've got like a chess piece on insert. Something about where do you get your piece? So pawn gets material, mesh 1, everything else gets mesh 2. How many meshes did I actually create is the better question. So chess piece king gets mesh 0 and then mesh 2. Technically we're not spawning anything else, so pieces. Match piece, mesh, assets, meshes. Okay. Piece assets. When I spawn you in, I make a cube and a sphere. Okay. So we should probably say something like let cone equal. Except you should only be 0.8 higher, I think. Cone 20. Cone. Something like that. And then we do that. There we go. Okay. Yeah, sorry, I don't know how long your message was. So I'm making n-dimensional chess. So the idea is that in chess, you've only got the two-dimensional board, and each piece has like rules about how they can move, but the rules are like very generic, generalized, but everyone goes like, this is how a piece moves. But like in reality, like a rook doesn't move like just up and just across. The rook moves any distance in one dimension at a time. So in theory, we'll go back to our actual running game. So we have our chess pieces here, and we go, so this chess piece, so we go the ampersand. So this is the pawn. The pawns, their movement rule for n-dimensional chess is that they can only move in the 0th dimension, or like technically the first dimension, because we're three-dimensional beings and whatnot. But so they're only allowed to move in this dimension unless they're jumping. So when we get to here, because we're in n dimensions, they can, because pawns can jump diagonally or take diagonally, they can take any of the pieces that are diagonally one away, but they can't step forward. I don't have any other pieces programmed yet, but the idea would be the same with the rook. Instead of the rook being able to move, forward and across, the rook can basically move any distance, basically up to 8 steps in one axis at a time. The bishops, I haven't quite worked out how they're going to work, because theoretically a bishop moving any number of squares in all dimensions makes them very limited in where they can move, but also because of the exponential growth of the pieces, it does also mean that theoretically you would have just an absolute shitload of bishops that they could probably get everywhere, but it would be like some bishops just can't move because they could all move. I mean, but the limited space where the bishops could actually end up I'm trying to think of a real chess game. If we open up just a regular chessboard to try and elaborate this better. Send a big picture of a chessboard, please. Zoom in. So the thing is with these rooks is you have a light and a dark rook, where the light rook can only ever be on light squares because it can only ever move in one step in both dimensions. And so I'm imagining we would have the same concept of because the rook can only move one step in all dimensions at a time, means that you'd have a rook that can bishop that can only end up on the n-dimensional equivalent of black squares and white squares, the three-dimensional. So it's it can only ever end up in these certain set of squares. So whereas this rook can only reach a maximum of 32 squares on the entire board, no matter how you move it. And same with this rook, rook's bishops. The same thing would apply, is that there's only so many squares it can reach. And so I think the same thing would happen is you would have, in 3 dimensions, you would have 16 of them, I guess. And the 16 of them would be restricted to a 1/16 of the board. But I don't know if that's how it actually works. It may actually be possible for them to get onto the same subset. And then the knight, again, one of those, I'm not really sure how it's going to work, because I was thinking it has to move incrementally more in each dimension. But that means that once you get beyond 7-dimensional chess, you literally can't move the knight, because the knight will have to move more than 7 squares in each move, because at the moment it has to move 2 squares and then 1 square. So you can any 2 squares and then 1 square. So in any dimension, it can move. Okay, it can move incrementally more in each dimension. So I guess the way to think about it more is it can move 1 square and then 2 squares, and then it can move 1 square and then 2 squares, and then 1 square and then 2 squares. That's how the knight moves. And I'm thinking in 3 dimensions it would move 1 square, then 2 squares, then 3 squares in the 3rd dimension. It's I'm thinking maybe just let the knight choose how many dimensions it moves in, because otherwise, again, you get to 7 dimensions and then the horse can't move, because it literally needs to be move 1 dimension, move 2 dimensions, move 3, move 4, move 5, move 7, 6, move 7. It was 7's outside of the play space. It's physically impossible for the horse to move, because it's always going to end up outside of the play area. But it would be really funny, because it means that some horses would be able to zip across the map, but very, very uncontrolled once you start traveling very far distances. If you start moving more than 4 or 5 dimensions, you're starting to skip across the map. So I think that'd be really kind of funny. The other issue is to make sure that there's no point where a horse spawns that he can immediately checkmate the king, because it just happens to be that if it spirals the right way through the dimensions, it just ends up on top of the king. And And I mean from spawn, because obviously further into the game it's fine, unless it's like literally two moves and take the king. Anyway, queen obviously could just move in any number of dimensions in any direction. I think you might have to nerf the queen, because obviously being able to move infinitely in every dimension means that the queen can like ridiculously travel through the map. But maybe not, because again, as you start to expand into higher dimensions, volumes move funny, because like obviously the queen's really powerful because she can jump here and then she can also go all the way in this way and that way. But like when you go to 3 dimensions, it's like, yeah, she gets a sphere around her and then also all the strands, but like the strands get further and further apart more quickly, so it becomes like it's actually bigger and bigger areas where the queen can't threaten without at least being more than one move away. Whereas on here it's like there's only these squares here that she can't threaten on the turn that she's actually moving. Whereas on 3 dimensions, like those volumes grow bigger, so there's more places you can hide from the queen in a single turn. And then king obviously just moves one space in every direction, so the king's pretty easy. The hardest thing about the king is working out how to make an iterator that actually iterates through all the possible positions. Okay. So let's work out, where were those kings? Did they place correctly? It looks like it, because they were somewhere. There they are. We've got our 2 kings. Obviously not programmed to do anything. Does that even look right? It's 3 spaces. Yep. Alright. So I guess we program in our kings, because I think we can select them, but they don't have any moves programmed in. Lovely. Kings are going to be really fun, because they're going to be able to skip around just about anywhere. And yeah, there's lots of stuff that I've like logically worked out, like why I have to do it a certain way. Like, as you'll see, there's pawns everywhere, and it's like, well, why have so many pawns? Why not just have like a certain limited number of pieces? Is because like theoretically, a lot of the balance in chess is that the pawns have to move out of the way to let the more powerful pieces out. So if you don't have pawns just absolutely everywhere like that, like they're literally like hemming everything in, you end up with the issue of like a piece might be able to just move from spawn like right into a threatening position. So instead you have to move a pawn, and then that gives the opponent a chance to move a pawn, and the whole thing kind of gets a bit weird from there. Select one, update piece position. Where is my movement code? All possible moves. Here we go. So this is where I program things. I also want to make it generic about like how pieces are moved. So at the moment, I'm hard coding in how pieces can move, but with like balance reasons, and also just like to let people make their own pieces types and stuff like that, I want to make it so that like it's like a scripting language that you can specify how a piece can move. Now here's the fun thing. Kings. So I need to probably go to teams and have an opposite piece. So because kings can move, I don't actually need the special logic to make sure that they're moving in the right direction. So we can import 10 and then be like opposite. Cool. It's like the arrows listing. Okay, so a king. How does one iterate through all dimensions? Do I have a position iterator? I do. Piece. Okay, iterator for piece iterator. So self-iterator. So I kind of need a I don't know why I called it piece iterator. Alright, so we're gonna go to position and we're gonna add like a dimension iterator. Position, dimension, range. Dimension iterator. Position iterator. How do you work? Position, current, dimension, end dimension, current iterator. Range. Okay. Alright. So I need to go maybe make it generic. I don't know. This is going to be a bit tricky because I can't in my head see how this is going to work, but we're going to make a hub struct position getter, which is going to take out a const distance y32? No, u32. I don't know if I can do it anyway, because it might tell me that I'm not allowed. Okay, so we don't need a position. I need to, I guess current. Interesting. So positions probably need to. How do I do that then? Distance. See, I think I want to give the offset of -1. See, what I'm running in my head is like, I need to probably modify this to actually be an I8, because the board's never going to be big enough to not need it to be. If min is less than 0 and abs of dimension I minus delta. I hope this doesn't break my code, but it shouldn't, because I'm not going to change how anything works in terms of they're all just still going to be the same. V dim value all but. Okay. I just need to be able to store a negative value so that like you can represent negative. Maybe. Why does it unwrapper 8? Shouldn't be unwrapper 7? Maybe. I'll leave it as 8 because I don't know why I was doing that. Anyway. Index. Not buy it, please. Interesting. And then index, get index. Interesting. Right. No, I don't know. I've already got position iterator, but it didn't work how I wanted it to work. So distance. So distance is going to be u8, just for like the sake of specifying it, which is interesting. After we specify it. I kind of need a range, don't I? I'm not sure. How did this one work? Because it's just like a recursive loop. So like the recursive loop, how did you, so you have a current dimension, end dimension, current iterator, which is a dimension iterator, which generates through the dimension, and you have a range. Okay. It's just boring. So we want something like current, and then I think that's it, really. So since you iterate through a distance of 1, we would do something like impl iterator for new position. So we need a const dimension distance know that, then we need to go like item. Type item position. Then so next and say, hey, no. Right. So if position self dot self dot current dot last is greater than distance, right, as I32 as I8 return none. Okay, I need to work out a way of doing this position shit that doesn't use a vector, because it's gonna be very unfriendly to the computer cloning all these vectors around. I need to work out a way of compressing it into I need like I only need like there's only eight positions on the entire board. There's 8 wide, which is only 4 bits, so in 4 bits per dimension times we're going to set up 7 dimensions, we only need 28 bits, and then that would leave us with, if we used a 32-bit number, that would leave us with 4 bits to represent other stuff like positives and negatives. In reality, if we want to restore maybe 5 bits per dimension times 7s, so it's just a 64-bit number, we could store it all into a single thing and not use the vectors at all. The trick is we want to use something like a small vec, maybe. And also, is performance really going to be that big of an issue? I don't know. There's no point optimizing it now because, you know. Okay, so let out position self current client. Right. And then for I in self.current. Okay. If self.current I is less than 7. Okay. No, so the ironic thing is I don't actually need the position to do it. I just need an offsetting position. Right, so what we need to do is we need to say let out fuck me, and then we say self dot current 0 plus equals 1, and then we say if self dot current dot 0 1 0 9 is greater than distance what? Okay. Why am I 8 complaining? It's because it's if. Okay, so if self, so if the current I is greater than distance, I, if I plus 1 is equal to current to n. No, just say so if we were saying there was 2 dimensions, there's something I need to go and test because mentally I've done it before. Where did I do it? I think it's in the piece iterator, which be back here. So we say if current is greater than 7 and I does not equal 0. Why are you I not equal to 0? Because you're iterating down. Why am I iterating down? Who fucking knows? God knows why I'm iterating down. Why am I iterating down? Doesn't matter. Okay. So if current self.current I is greater than distance. I want to say greater than equal here, but that's going to cause issues. It really shouldn't be an issue if I just increment. So we say I equals 0, and then current I plus 1. That's where the issue comes from. Well, I guess that's the trick, isn't it? It's just, if we just said maybe length minus 1. We don't need to increment the last one, because if it wraps around, cannot borrow. What? Oh, it's not a 0. Okay. Okay, so the idea is that this should increment. This will increment the 0th dimension by 1, and then we iterate through all dimensions, and we go, hey, if the dimension is greater than the distance, then reset the current dimension and increment the next dimension by 1. Then we go to the next dimension and go, hey, did you happen to now increase greater than the distance? And then we keep doing that until we're done, and then we send out the value that we had at the beginning. Then, next time we come in, we go, hey, if the last value is actually greater than the distance, which means that we've done enough loops to get to the end, just return none. And then that shows that would happen. So, lovely. Okay. So then we should be able to use that to iterate through all positions within one step of the king. And then by iterating through all things that are one step within the king, we can then do the check to make sure it's not your own team. So for king, we need to go for pos in new position iterator with a distance of 1. No. Alright, it's more gonna give it something like with offset, and then we're gonna say where the hell is the current position? Just position, isn't it? Yeah, position. Position with offset position. Interesting. Not minus. What, deck? I don't no, not deck. Deck all. There's a lot of cloning going on. Deck all. So we have to go add a deck all function like that. Let me do this. Okay, so we go here. We go, hey, so you need to impl with offset, and then this is going to return a no, current is just going to position. Yeah, no, so this is just position no. No. What? The hell? I think this is the wrong position. Okay, that was correct. Vec, no, 0 by offset.len. Okay. Yeah. Right. So we have this with this. So next we need to make an offset. So it's pub struct offset iter, which takes in this needs to be a t, which is iter whose item is equal to position, like so, and then the base and iter, and then we do this. What? Okay. Iterator P. Need this, please. I don't want to specifically implement an iterator. I want to do that position, and then position plus self base clone. Okay. I don't think I need to clone you. Doesn't plus take in? Okay, I'm going to say dot add then, because that's annoying. We just need a reference to you. So we're mapping position. Yeah, okay. So we're missing a whole bunch of things we need to add a position. So first off, position. Yeah, I thought I had a, right. And there's no way to say that this is a reference. No. Okay. And you're annoying. You move, but that's fine. So we're going to just add our own add like this, which takes in self and other, which is a reference to position self, and then it says zip the two together and add the two up. Like so. Oh, it's just so good at some of this stuff. Like the AI really zips along some of this stuff. It's great. So found in mute. Wait, what? No, position doesn't add anything. Yeah, return. No, you just do this. So first off, do this, go it's MP. But I need to make you mute. Right. So we map it by taking it, we add the other one, and then we return it. Now we could make it consume it and then spit it back out, but that seems like extra effort. That's our offset iterator. I don't remember what else we were doing. Oh yeah, we need a what? Why are you returning this? No. So we need a pub deck all. Okay, and a pub ink all. Alright, cool. So I don't remember what were we doing, where we were doing it. Something here has gone terribly wrong apparently. Right. Index I. Oh, hang on. Goddamn time. Okay, so then we go back to pieces. Right. So we say king and we say hey with offset, position, and then default. So we're taking the king's position, we're decrementing them all by 1 because that means that we don't have to make sure that this starts at -1. We can just start at whatever we start at. We can start at 0 because we're basically saying get the position down 1 in every dimension from the king, and then we're going to iterate through +1 in every dimension from the king, which actually I believe is it should be +2 because 0, 0, 0 would be -1 from the king, and then +1, 1, 1 would be where the king is. So 2, 2, 2 would be out the other side of the king. So we're going to say if position equals if pos equals position, we want to continue because we don't want the king to be able to move if the king is already there. So if let some other equals board.get pos and let okay
I don't know if this works, but can we say that's obviously not going to work because it's not the same thing. Team equals pieces dot get other ampersand other team equals not, well, yeah, equals white. I don't even need the opposite because I already know what team I'm on. It's here that we need the opposite, but anyway. So you would need this. So first off, this shouldn't be called white. This should be team. Okay. So if it equals team, and then otherwise move stop push. I believe that should be all that we need for the king to be able to move in every direction one step. Why is YouTube yelling at me? I have no idea if my code's even working. Check that. It does not appear to be. Apparently, my code is still broken. It's annoying. Why is it not automatically running? Also, why does it always keep re-rolling the same fucking number? Did I make certain numbers more? My auto retitling code is apparently broken. I don't know why it's broken, because if I hit the button, it redoes it, and it works. So why the fuck is it not doing it automatically? All right, let's. Do that. And then we go, this is that's valid, don't bother with that, don't bother with that. That. Then we come up here and we go app.add systems fixed update title forced app.insert resource fixed when fixed from hertz from seconds, we want to say 600 maybe. I'm just gonna do this. I'm just gonna rerun this, and maybe it'll work this time. To be honest, I don't know why my timeout logic isn't working, but it's almost certainly just something like instants don't work like I think they do in fucking code. Also, something about a 1080p to like a 4K to a 1080p monitor means I can't move Bevy apps across because they get bigger faster than I can move them from one screen to the other. Okay. Maybe it'll retitle itself now. I don't know what my retitling code, like, I don't know what's wrong with it, but fucking, it's not working. That's my retitling. This one. All right, let's go find those kings again. There they are. And then I should maybe, like, I want to add all the pieces and then add textures. Okay, so that king apparently just can't move, which is interesting. Neither can that king. So, neither of the kings can move. So, question is if we said, like, hey, print line. This will tell me all the positions that it's trying to check. And then we can work out if they're actually, like, relevant positions. Because there's also just, like, a non-insignificant chance that it's just not. Okay, so it is checking. Well, first off, black king seems wrong, because I don't think black king should be all zeros. Why is the first place you check 0, 0, 0? That doesn't seem correct for the black king. Or for the white king. None of the kings should have 0, 0, 0. So that means that it's probably my offset iterator. It's not working. So you're with offset, which... No, you don't return self. That would explain it. It returns a offset iterator. No. The base is that one. Like so. And then the offset is offset. Like so. Mismatch type, expected structure. Yeah. Okay. So first off, this is just not going to be something that you have. This is just going to be, no, maybe, I don't know. You have new and then you just return self like this. Except you need, dimensions. No, you just need the size of the number of dimensions that you have. And this is 0 dimensions. Okay, and then we're gonna make a new trait. Trait with offset. With offset's gonna have a pen with underscore offset. Where self is sized plus iterator. Define an item with offset. Okay, and then we need to import t with offset t. Okay. And then we go here and we say, hey, it's actually new dot with offset. Is that how that works? Oh wait, no, we need a turbo fish here as well, right? Like this, and then we need to say that your number. No, you take in the number of dimensions new, and then that would be our position. Dot len. We need to bring in use I want to say break board with it's not public. Oh, it's not there anyway. Board. Pub with offset. Okay. There we go. So that should now result in the king being able to move in any direction, as long as it's not blocked by a piece of the same color. Right.
not quite correct, but more in the sense of apparently I haven't made it so that you can't magically step into the shadow realm of the wrong dimension. Okay. Right. So we do need to assert that if I guess is it with offset that needs to make sure that it's valid? Who validates these? See, because I would rather the iterator skip over the invalid ones. It's obviously not the offset one, because the offset one literally just checks. But you can't check it. Yeah, because you don't know what the offset is. So you're always valid. Not the offset iterator. You're always valid. Because you never return a negative number. You just iterate from 0 up. So you're never invalid, so it's actually impossible checking you. So I guess it's the offset. So I guess it's wherever we implemented iterator for offset. Offset iterator. Iterator. Next. So I'm just say like let out equal that, and then we say like out dot is valid if okay, and then so we need to work out the out is valid, and then we say is valid, and then we're saying so if it doesn't contain 0 to 1, return false, and then return true. Okay, so that should hopefully not end up in a fucking infinite loop. And more or less eliminate any of the ability to... Okay. So now the king, okay. Let's remove a pawn so that the king can walk out and make sure that the king can actually move in every direction. But I'm going to say that the king is almost certainly doing what the king is supposed to be doing. Ah, come on. King, go. Okay. So, king can, like, get just about anywhere. It's awesome. Okay, and then king should be able to take any piece, because, you know. Lovely. Lovely. Alright, so that's a king implemented. What do we move to next? Really the queen. Queen seems fairly straightforward and simple to implement. Maybe not though. Actually, we should add the rook and the bishop because they'll have their own iterators, which I think I've already made one of them. But the advantage of those is that the advantage of the rook and the bishop being made first is then the queen is literally just merge those two iterators together, and then that's the queen. So again, I'm trying to think that maybe we need to nerf the queen so she can't move in every dimension at once. Maybe she can only move in 2 dimensions at once, because it still gives it a huge amount of movement, with especially considering that, like, theoretically there's going to be lots of queens. Like on a 3-dimensional chessboard there's going to be 8 queens, because there's going to be a queen on every layer. There'll only be 1 king, but there'll be 8 queens, maybe even more, because we still need to fill in what the king's going to be when the king's not there. So, you know, there's that. So I guess I need to work out where we're going to spawn the rook. So I also feel like I need to tweak how the spawning code works,
Because at the moment, the spawn encode is like I need to check both positions when I feel like it should be checking. Oh, so I don't know where I'm going to spawn the rooks. Like, what the hell is it? Where the hell do the rooks spawn? Oh, I guess the rooks spawn when all dimensions. See, because all dimensions means it doesn't fill very well because we need to fill all of the column. Maybe not, but I need to come up with more pieces then. So the rook needs to fill anywhere that without hitting the king. It's the important part. Without lowering the king, because when what's the logic? When we're in one-dimensional chess, we only have a king and a pawn. So the rook can't just be whenever this dimension is equal to 0. Because it can't hit the king. And I don't feel like hard coding, which in theory, like, this should work, because did you return? No, you spawn a piece. I think each of these needs to continue once they're done. So because if I don't continue, I mean, technically, if position 0 does not equal 0 and position 0 does not equal 7, continue. Right, so then we can get rid of this logic. So we probably need to set the color though. So let team equal. Okay, so then we can probably get rid of the logic that is like, hey, check this. So we say all bar 1 is 7. So then we're going to say, hey, so your team so you should all be exactly the same. So I want to go like something like if team equals white. So try to make this more generic. So we need to be like so let new piece equals command spawn. No, just go to the okay. So we need to say whack in our position, whack in that we're a king, whack in that we're on this team. Right. So we need to do all that because that's how you determine what you're on. And then so if team is white, then we need to go piece.insert and we do insert name white king and the white material, and then we say else black king and the black material, and then position, if position is visible, piece insert visible, else piece insert hidden. Okay, and then we should be able to do this, and we go, hey, okay. So this is the king check. King check. Alright. So the idea of that is because if we check the king first, it means that we don't have to check that the rook is in the right spot. So we're going to say sure. All bar 1, all bar 0 is 0 and all bar 0 is 7. And then we say, hey, piece spawn. So position rook team. That's how that works, yeah? Position rook team. Yep. Okay. And then if team white, white rook, and then material white, and then a black rook, and then material black. Then we continue. Okay, so that's all the rooks. Well, that seemed very straightforward. Terrifyingly so. Now we have to go to our assets. I feel like we might need to modify these assets so that I don't have to fucking keep indexing into them. So we kind of want to go something like let still equals, okay. Then we can just copy the correct spelling and say cylinder, and then we're going to say, hey, any chance that we can make the cylinder? Maybe we should put them in the right spot. So pawn is 1, rook would be 2. So we would want to go cylinder. Now somewhere we do this and we say, hey, actually king, can you be king can be 2, and then rook can be 1. Right, so that gives us a rook in the cylinder. So and then we need to work out how to make our rook piece work. Okay, so I'm pretty sure I've already got an iterator that lets you iterate through any singular dimension. So we say rook, and then say 4 axes in 0 to dimensions. For direction in -1, 1. Let mute next position clone. Okay. That seems very, very weird. It might be a fast way of doing it, but I'm going to say 4 axes. Dimension. I guess. So what was it doing? So it's a 4 direction. -1 and 1. Next loop. Okay. Position clone. So loop, if direction is 0, it apparently wants a deck in place by axes, else ink in place by axes, and then next, if next is valid, break. Not valid, break, okay. So that breaks this loop, okay. Then we say, if let some other equals board.get, ampersand. I think let's click this, right? So we say if the other and this if other team does not equal team, push and break, and then and otherwise we push the move. That actually seems like a really elegant way of doing this without any like. Obviously, an iterator would be cooler, but like that seems like a good way of doing this. So we want to like apparently we need to implement deck in place, which is fun. So we need to like hub ink in place, fixed mutable self, and dimension. I'm gonna get mute dimension, and then we can comment dimension. Okay, and then we need a hub. Deck in place, which is doing the same thing but decrementing it. Okay, and then we go See, that still feels like a very, very elegant logic. Question. We have 1 rook. Okay, so that's just, I guess it's because we've said all dimensions need to be 0, or all dimensions need to be 7. Now, ironically, the rook, as you can see, can move anywhere along this line, or anywhere in any of these corners, and then in theory any of these corners. And then, I feel like, and then any of those corners, so there's 1, now the rook's blocked in the forward, so there's 1, 2, 3 dimensions that the rook can move in. 4, and that would be 5, and we're in 5-dimensional. So that's, yeah, it can move in any direction. It's just not nearly as intuitive. I thought the rook would have been able to move, like, kind of any diagonal. But I guess not. It's weird. That's moving, oh, because that would be moving in 2 dimensions, wouldn't it? Because he's got to move one that way and one that way. So he can't just move to any corner. Weird. Okay. Strangely unintuitive to how he can move. So that all works. What was I... There was something about it that wasn't quite right, though. Oh, right. It's the spawning of them. That's not right. That's right. It's only spawning one of them because we're currently only select one. Where's the spawn pieces? Spawn pieces. So we're saying if all bar 0 is 1, that's not correct. It's more like if it's not all bar, it's if one all but no what would it be? It'd be like if is so we're gonna say like 1 0 and then I knew it'd be like 1 7. I don't know if that'll work. If is, and then we go to position, we track down position here and then go if is, and then self dim u signs, and then val y8, we return a bool. We say self if let some self var b equals self dot get dim ampersand. V equals val true else false. I think I need to flip those. So val equals v. Nope. God damn it. Why can't I compare those? That's annoying. Okay. So if I was to run this, now the if equals should translate to, are we having a black rook in every corner and a white rook in every other corner, and then we can be all like meow. Now we gotta like work out, can the rooks zip around? So let's grab the pawn, move the pawn out of the way, go, hey rook, zip. You can take, yeah. Zip. What can you go? Anyway, you're a bit limited by the fact that you've got to take a piece to get there, and then you can go like here. Okay, so rookie seems to be working really well. Rook can rook around. Then the white ones, they work too. Okay, gotta move you the fuck out of the way. And then we go pyong, pyong, pyong. Okay, so that's the rook working. Now I would rather be an iterator, but I don't think it can be an iterator because of the fact that I guess it could be. Okay, so how do we turn the rook logic into an iterator? So it iterates through every dimension. And then it iterates forwards and backwards. And then it loops through in place, checking
that each one is a piece. Okay. So I think I have a dimension iterator. Now we have this inc in place and dec in place. Maybe we can make that dimension iterator better. I don't know what uses the dimension iterator. We should probably check that. I feel like I can redo you, but what uses you? What actually touches the dimension iterator? You do. You're all still the dimension iterator. Your implementation of the dimension iterator. So you use the dimension iterator and your position iterator. But then what uses the position iterator? Like what's going to break when I take this away? So you're the new position iterator. What actually uses the position iterator though? Something in here is the position iterator. Right. I feel like technically I should be using the king. Alright, so as long as I don't like actively break that implementation, which will break the pawns, but I feel like we need to use what the AI did, because it's just such an elegant way of doing it. So we need to be like current. Be like position. Dimension, and maybe up, which is in a bool, and then we go, okay, so get rid of all of this logic, because this was about not letting the player specify an iterator that was not able to be done. Okay, so I reckon we do something like that. We go dimension iterator, we go, hey, so fn new dimension, which is the U size, and a inc, which is a bool, and this returns a dimension like so, and then we say dimension here dimension. This needs a dimensions, which is the U size. Dimension. Okay. Then here we say iterator, and we go iterator, and we go. So how did you work? Oh, so amazingly written piece of code. So it basically just said for each dimension, for the we go up, we basically just increment in place if it's positive, or decrement in place if it's negative. And then it's kind of up to the user. Alright, so we say we go if self dot current is greater than, actually we should probably flip you. No, you can go down. I think you probably want to go start at 7 and go down when you're below, but it's if current 0 is greater than 7, or self dot current 0, no, it's not 0, it's self
self.dimension. Self.dimension is less than greater than 7, less than -7. Return none. Right. Okay. Then we need to go something like debug assert dimension is less than dimension. Okay, so if yep, I said so. Then we need to go, hey, if self dot up, then well, let out equals self dot current dot clone, like that, and then we say self dot current dot in place dimension, so it's self dot dimension, self dot dimension, else self dot current dot dec in place self dot dimension. So increment or decrement, and then return sum out. Okay. So I think that should work, because that should be doing the exact same thing that that's doing. Then this is obviously doing extra steps to then check the logic, but this is the actual decrementing incrementing step. If next is valid. So this will increment decrement the whole way. There you go. So you can increment up to 7 and down to -7. And it'll always increment exactly 7 times, maybe? Yeah, because it starts at 0 every time. And then it should have a with offset, and obviously with offset checks to see it's in range. Okay, so that should work. That should work. Okay, so this is the current iterator, which is then a dimension iterator. Right. I don't know why it's an option, but I'm going to say sum. Okay, then what did you need? You needed the number of dimensions, which is, I guess, pos the len. The start dimension. Okay, so current dimension, start dimension. Yep. And then your range, which is to say, right. Let's go with up. So true. Alright. Let inc equal range dot min dot unwrap for 0 is less than 0, and then we pass in inc. So basically, if the value is negative, pass in inc, and then we pass in range. So range dot clone. Something like that. Okay. No, this would be dec. Start negative dec. Or I guess it's greater than or equal to 0. I don't know. Start with positive if it's 0. And then so then you would work that you say next, and you say current iterator has me next. Right, return some next. current dimension. So when this returns none, we increment the current dimension by 1, and we say if the current dimension is higher than the end dimension, we return none. We should probably do that first, because otherwise we're going to keep incrementing forever. Okay, so if current dimension is higher than end dimension, right. Okay, and then we say, dimension is ready to know, and then we say something like self position len, and then we say self.current dimension. Yeah, I don't think this needs to be an option. Like so. Okay, and then we say self range to clone. Okay, so then we need to work out if you're wait, okay, so we need to go okay, what am I doing? What I need to do is like work out if we started incrementing and we weren't so we probably need to have like an inc and deg rule, right? So we say, hey, increment, if that's positive, we start increment. We started an increment. So call that dec, right? So we're gonna start at decrementing because it's less than 0, and then let inc equal range dot clone dot min greater than or equal to 0. I guess it's greater than 0 because it don't need to do it if it's a deck. And then okay, so and then we can pass in I don't know, this feels wrong. I feel like you need the same thing where you like a const distance you wait like that, right? And then we say like const distance you wait distance like that, and then and so that wouldn't, none of that would change because it's all just exactly the same. But then down here we say if this is greater than distance and then negative. Alright, so distance is going to be, we're going to make it an IA because it means that I don't have to fucking cast everything and I can use negative. Okay. So now it all works and we can specify distance. So I think we need to now make you have a distance. The issue with fucking generics is that they infest everything. Right, put that, and then we say, oh, and we still need fucking A. Only because I'm keeping track of position for some reason. You, okay, anyway. The fuck? No. Go here, go distance, okay. Okay, so,
thing is you, like, I want you to do like a plus pattern. You need to check and then check in each dimension. That's what you do. So let's just restart. So you're doing something different to what you originally intended to do. So let's go. What do you contain? You contain a iter, which is a dimension iter that has the same distance as you. Okay. Let's say current underscore dimension. I actually should check that my renaming code is actually working this time. Well, now it's just screaming at me, refreshing token. Well, that's not good. Well, can't imagine how Google's happy with me about. Can't imagine they're happy about that. What the hell is refreshing the token continuously? What print refreshing token? Refresh token. So something's triggering this event continuously. So it's called every frame. What is calling that? I think that you're calling that, and you probably shouldn't be calling that every frame. You should be giving it time to fucking sleep, my dude. If right, dot sec. Okay, then we say here, and we say here, we get to here, and we say cooldown. So you know what, I think my auth enjoyed that. Okay. That wasn't clever. Alright. You guys have no idea what I'm doing around the monitor, but they got an auto renaming script running that should be renaming the YouTube video every 10 minutes. And I go to check on it and it's just screaming at me that it's refreshing the token over and over and over, which I don't think Google's going to be happy about me constantly trying to refresh the token. But what it was doing was I have it checked to see if the token's valid every frame, because otherwise, it stops working because the token invalidates after an hour. And then it was going, oh, okay, refresh the token, and then obviously the next frame it went, the token's invalid, refresh the token, and it was like it hadn't finished pinging the server to get the new token yet. So I've given it a 10-second cooldown where it goes, hey, my token's expired, get me a new token, and then it waits 10 seconds and goes, is my token expired? And yeah, so who fucking knows? Now I've got to go here, I'm going to go F5 to find the current live stream and start updating its title. Making over-engineered chess in Bevy. What could go wrong? Yep, cool. I get a random name generator for the fucking thumbnail, for the YouTube video, for the live stream. It just changes its name every 10 minutes. I don't know if it's been working. That's the hilarious thing. It's like, who knows? It probably worked for like an hour, but then it probably stopped because again, like it was trying to refresh the token and it wasn't waiting long enough for the token to be refreshed. So anyway, so in this dimension, that dimension, and then we're gonna go new. Now the question is, do you actually need an offset? Probably not, because I'm gonna say like you don't need the A anymore because you're just gonna do this and you just get rid of that. Like that. So we go new and then it's a new position iter with distance. And that's probably going to be something like now I think that the idea of the distance iterator is probably going to increment up and down, not just down. Okay, so let me just say like position iterator with an iterator being a new. Okay, so you need dimensions. Which is U size. You need to specify the number of dimensions, and then your dimension is 0 and your increment is true. I think, I don't know, I'm not quite following how that's going to work, but anyway, we want to go distance. I should also be committing shit to Git so I don't break stuff, but anyway, const distance 1.8 like so, and then we go, hey, right, so we do need dimension. Which is a U size, like so, and then for that we're going to say the end dimension is just dimension, so end dimension dimensions. If current dimension is greater than, so I think it must be dimensions minus 1 then. Okay, so then you return nothing like that. All right, then we say something. So if let sum next equals self dot iter dot next return sum next then we go, so we get to here, it means it returned none. So we can say self dot current dimension plus equals 1. Wait, no. Was inc is a bool, and we're gonna start with was inc true. Right. So if was inc, then self dot was inc equals false. Self dot current dimension
No, iter equals dimension iter new self dot end dimension plus 1 self dot current dimension, and int is now false. Okay, and then we say else self dot current dimension plus equals 1 self dot was int equals true self dot iter equals dimension iter new self dot end dimension plus 1 dot current dimension and true, and then we come down here and we say self dot next. Okay, so it's slightly recursive, but it should be fine because eventually it'll increment its way all the way through there, and just make sure. So if you're true, you become false. If you're false, you become +1 and then become true. Okay, so it definitely increments that, which means eventually it'll definitely overlap that, and the end dimension will eventually become greater than the current dimension will eventually become greater than end dimension, which means it will eventually end. Okay, so then we go back to pieces. We go, hey, position iterator. Hello. So we need to say that you are a position iterator. New. The dimensions is dimensions. And then dot with offset. Where the fuck is current position? Position. Dot clone. Okay, so how do you not have a distance specified? How are you working with that distance is the better question. Are you going to complain about the fact that you don't have a distance? Apparently not. So if team white position get, so you increment and you decrement, which is okay, weird. Position iterator new, and then we say dimensions and width offset position clone. Okay, then both of you need a distance of 1, I want to say, because again, like this should in theory go plus or minus distance, plus and minus distance. So that should be a distance of 1 and 1. Now, theoretically, this isn't going to work because it's going to check all dimensions around the pawn when we need it to skip the forward dimension. Right? Let's just go back here. So you were going from dimension 1 to dimensions minus 1, so all dimensions except the first dimension, and you were going from -1 to 2, which is plus or minus 1. Right? So first thing to check. The answer is no. Distance is less than dimensions. Assertion failed. Dimensions is less dimension. Oh. Oh yes, of course. I don't say less than or no. It's very much a bug. If you ever request a dimension iterated over a dimension that's too great. So we say end dimension +1, and let's say current dimension. See, that makes me want to go, it has to be custom. So dimensions is end dimension +1. Well, the thing is if I did plus then or equal to, because that should obviously stop at 1 dimension earlier, so it shouldn't actually hit this case. And then so it shouldn't crash. Okay. So that's fine. Fine. Okay, so you're not finding any of these? That's interesting. Okay. So pieces, we go pawns, we go, okay. So And then get rid of the book. Pause. So why is position iterator here? Can I print line position? It needs to be the debug. Okay. So what exactly are you trying when you check all of these? So you are checking like everywhere really. That's not correct, but anyway. So when I click here, you are checking 0, 0, 0, 0, 0, 0, 1, 1. Why are you sort of arbitrarily checking other places? So 3, 5, 4, 5, 3, 5. See, this isn't working because this is giving me the same number. When it shouldn't. Something should have incremented here. And then it sort of arbitrarily increments one of these. So we incremented, decremented. Wait. So 3, 5. I think. I'm not sure. So this is 3, 5. Alright, let's go back to here and let's go, hey, can we print line start. So position. Like that. So this should tell us the starting position. And then increment through all the positions. So when I click you start at 6, 7. The first place you try is 6, 7. You then try 7, 7, and then you try 6, 7 again, which is very much incorrect. So 7, 7, 6, 7, 5, 7. Okay. Well, that seems kind of right. Then you try 6, 7, and then it should be like 6, 7, 1, but it's not 6, 7, 1. And then it should be 6, 7, and then 6, 6. So what the hell are you doing, and why is it not working? So right. So possibly what's happening is because each time I reset it, each time I do you reset to 0, 0. So we might need to call next to get you past 0, 0. So you increment along dimension 0. True. Okay. So if cell current dimension. So what are you printing out though? So that would be 0, 0. So I feel like I need to skip the first. It's kind of the issue with the dimension iterator here is it does start at where you told it to start. So we could say like self.iter.next. And then same with you and like self.iter.next. Something like that. And then we go, what do you come out with now? So you still spit out the first one, which that's fine, because that's just like the check that position. Then you go +1, -1. you're -1. So +1, -1, -1, +1, +1. So it's just not working, for one thing. It's just very arbitrarily numbered. God damn it. Why? So we need to get a +1 here. So what the hell's going on? Can I get you to print out like everything that you're ever returning? I need you to print next. Oops, next. Like that. No, like what is coming out of this? Because I feel like I'm skipping a whole bunch of things because they're like becoming invalid locations. Like it's printing out a hell of a lot more than it's actually using. We probably should have marked that one. So we get 0, 0, 0, we get 0, 0, 1, 1, 0, 0, 0, then we get -1. Then we get 1, -1. So it's skip this one. It didn't print out a number in between. And then we get 1, -1, 1, -1. And then for some reason we just don't touch that final dimension, which, right, is because less than or equal to. So first off, does this cause it to crash again? Yes. So somehow that makes even less sense, to be honest. So doing that gets us into that final dimension range. But for some reason, when we're in that final dimension... It's because we initialize it and then go up here, and then so that would... So... I feel like if I did this, maybe it would give me that final dimension without crashing it. It's just it never puts out the final dimension. It never reads out the final dimension. If it doesn't read out the final dimension, then it doesn't check the final dimension. Okay. Yeah, okay. So we never get the -1 in the final dimension though. Okay. Yep. So put you back here, and put you here, and we need to go, hey, like, I need to remove this assertion. I still feel like it's going to have issues where it can possibly crash because now we can request outside of a range, but anyway. Yeah. See, index out of bounds. Why? Why? Okay, so I'm thinking it's because it can get back into here before it increments the dimension again. So maybe end self dot current dimension does not equal self dot end dimension. Does that fix my indexing out of bounds bullshit? Nope. Why? If anything, it went worse because I got rid of the -1 again. So is it this? Else if does this fix it? I think the obvious thing is we gotta leave that in, because if it's hitting that, then it's the problem. Okay. The thread overflowed at stack, which is fun. My guess is because you end up here calling next, which then, because this isn't the case, we'd call. Then we get to here, which then also just is going to return none. Which we get. Okay. Maybe that will work, because I think what was happening is it was getting to none, and then it was just recursively calling itself in forever. So yeah. Okay, so it works now. I don't think it's giving me the right numbers, but so why can't I jump you? Alright, so I think you're out, you know, so you do 0 and then you 1, and then you -1, and then you do 1, -1, 1, -1, 1, -1, 1, -1. Right, so it is outputting all of the numbers. So you, position iterator here, are in fact outputting all the correct numbers. Which means that it's the offset iterator that isn't. So I want to go like print line. Why is my intelligence gone away? Okay. Out, and then we can say offset. Okay, something like this, and then we should be able to work out like the. Except what I feel is happening is the offset iterator is determining that like we're getting negative numbers and then they're invalid and that's not spitting them out. So our offset iterator says here, and then we get that position, and we say it's here, and we get that position. We say here, we get that position, and we say here, which is 6, 8. Yep, that makes sense. That shouldn't come out. And then we go 6, 6, which it does come out, and we say 6, 7, which does come out. And then we say 6, 7 minus 1. Yep, that doesn't come out. Okay, yeah, because it's minus 1. And then we say 6, 7, 1, which does come out, and we say 6, 7 minus 1, which doesn't come out, and we say 6, 7, 1, which does come out. And so it's giving them the right numbers. It's just for some reason it's not working here. Why are you not working specifically? Like, why can you not find? Interesting. So what I've concluded is all the right numbers are coming out. Now somehow we need to tell it to skip the first dimension, which I feel like that's pretty easy to do. Yep, like pub start at, and then we just need to give it dimensions and dimension, which is the size, like so, and then we go that pointer iterator, position iterator, distance, position iterator, something like that. And then we say current dimension is equal to dimension, dimension minus 1. Okay, so then we can go back to here and say our pieces. Here we are into the black piece. We go, hey, so start at dimensions, comma, 1. And then your dimensions, comma 1. Alright, so that should skip the first dimension. So the next question is, why the hell are you not detecting this? So when position equals next, maybe I'm not supposed to be passing in position, maybe I'm supposed to be passing in next. What was I doing before? I was passing in next. Maybe that's the problem. Maybe the problem is that next is actually the correct position, and that's what's going wrong. If position is equal to next, continue. So maybe it's supposed to be next, but I'm checking. Okay. Well, it kind of makes sense that. So we are checking a sequence of positions. We're checking basically one up, one in every direction. Which is strange because I feel like you should be checking -1 in every direction. I'm also moving like the worst possible piece because it's like on the edge of multiple boards. So like if I moved you, do you check like a whole bunch more? Not really. So you check 1, 1, 1, 2, 0, 1, 1. Okay. I don't get what's going on. So if we pass it next, I think I've already done that, but next should mean it's checking like a position in front. Maybe that's all that was wrong. Maybe all that was wrong was that it was checking. Okay, yeah, so we just needed to check next. Okay. Okay, so that's fixed, and then that increment iterator should be able to be used in other places. Like, for example, or maybe not, but we go to the rook and we said, hey, for all axes, so next is valid, so that's some other board. So this is the actual check self. Yeah, so we need to move this outside of the two loops, and then we just say for position in direction. Better. Did I fuck up the spelling, or is it just direction iter, and then we want to do it in a distance of 8, I think is the correct answer there, I'm not sure. It might be 7. I think it's 7 because the most you can move is 7. Now, direction iter. Have I not made you public? Because that what the problem is? This is a position iterator and a direction iterator, no? So why the fuck can't you see the dimension iterator? Okay. The dimension iterator is 7. What? No. 4 in... What? What the hell is your problem? I don't know what its fucking issue is. Import this, please. Okay. Then we move all this stuff inside of here. And we go, hey, so this I guess is the next. So we'll never get an invalid position. Apparently new is private. Okay. So pub. So no. Right. And it takes 3. So dimensions. Dimensions is position dot next. Len. Then we want to go 0 incrementing through axes, and 0 increment is true. Right.
So then we say if the other of the board of next and the other of piece of other, if other team is not equal team, then you can move there, and then we break out of this. Yep. Otherwise, we push the move as a valid move, and then we say for next in, and then we just copy exactly the same thing. And then we say but this one is false. And then we go, that should work too. And then in theory, I should be able to swap it over to using a position iterator, because I'm pretty sure the position iterator just iterates through. Not quite correct, but I think the not quite correct is actually because you're supposed to have the offset. So it's supposed to be something like with offset position. Dot with offset position. Okay. Something like that. Oh, the answer to that one is apparently no. So what that, well, also, apparently that rook just ceases to exist. I think that's unrelated though. So what the hell is going on? Because it was working before. It just doesn't work with this offset. Is it not supposed to be offset by position? Okay, so again, we're going to go back to printing. Print out the position. I'm not printing out the pawn's position anymore, am I? Because that could get confusing. So position, and then it's just, and I'm going to say next. Something like that, something like that, and we go, hey, and we go, okay, when I click on a rook, so you reckon that the return result is 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, which is very much incorrect. So obviously your position is 7, 7, right? No, your position is definitely not 7, 7. What about you? What is your position? Apparently you're 7, 1. Okay, so maybe you are 7, 7. That would be 0, 0. No, maybe you 0, 7? Okay, so then why is it not incrementing? Okay, first off, let's move it up here. And run that. This is supposed to be incrementing. But it's like, it's clearly not. Wait, do we not want to break maybe? So it's running 5 times, which means it's running once per dimension. So first off, if next equals position continue, I think it's finding itself, which is annoying. Which is extremely annoying. So if it's finding itself, then that's why it's stopping after exactly one iteration, is because it's like, hey, I found a piece that is me. Yes, okay. That does appear to be what your problem was. That's hilarious if I move to here because there's no other rooks in the way. Okay. So better question is, why does this one rook decide that it doesn't want to exist? And it is literally just that one rook, right? Yeah. Just this one rook, which I'm guessing is because it's at 0, 0, 0.
So the rooks all seem to be working fine. Now I don't think I can condense this because or maybe I can. Maybe not. I don't think I can because I'm pretty sure you consume it. I was thinking what I could do is say because we need to break a line when we hit an enemy piece, we can't use the piece iterator because that won't let us skip a whole line once we've reached the end of it. So this is actually the best we can do, is to iterate through each axis individually. So when we spawn a piece, when we say, hey rook, if 1 is 0, so why the hell why if position all like let's say 0 is 0, can we print line missing rook? Well, I guess we should probably just go here and be like, hey, can you just pub all self val I8 will why is my IntelliSense just fucking busted? Except we don't need this bit, we just do this. We don't need the enumerate bit. We do that. We just say reference to V. Okay. So we can now go here and say, hey, if all 0, we just say missing rook. I want to know if it gets there, because it could be that it's returning early. So it's like if position 0 equals 1, it's not hitting that. So it's literally just never checking all zeros. Question. Go right at the top and go, hey, so this is the missing rook, right? My suspicion is that I'm incrementing and then returning. So like we just like literally never check position 0, 0, 0. So it never prints missing rook, which means at no point are they all zeros, which means the piece iterator iterates in the wrong order. So what we need to do is say, hey, so equals self dot current dot clone, right? And then we need to say, hey, current plus equals 1. Yeah, see, the first thing we do is increment that, and then we need to return out. So we were just literally never doing position 0, 0, 0, 0. And hence there was nothing there. So that's fun. We found the missing rook. Okay. So that's the missing rook. Okay. Rook, and then next is put them on the right line. So this would be, I guess, bishop. That's correct. Chess bishop. Bishop. It's probably no check. Now, question. Why the hell is my IntelliSense just not working? Weird. I wonder if this is still working. I've not had any luck with this fucking thing. Making 6 chess. D chess. Well,
It seems to have renamed it at some point. When was that? That was 29. That was like half an hour ago, so I don't know if it actually did it. Oh no, 440. So that was at 51, 52. Okay, well, apparently the auto renaming is working. Okay, cool. It took forever, but apparently that piece of code is working. Alright, so bishop. So how the fuck does bishop spawn? Now, my thoughts with the bishops is that they're going to be slightly harder to spawn in because, again, the rooks all being in the corners is kind of funny. The bishops, I feel like the bishops are all going to have a lot of overlapping places. Like they shouldn't be so spaced out, but they are. Anyway, the bishops are going to be the same thing though. They're just going to end up going and checking more or less the same logical condition. So it's if position dot position dot if is, so dimension 1 is so what was it, 0, so it's 2 or 5. Okay, 2 or position if is 1, 5. Now my intelligence comes back. Okay. So we say that piece, yep, become a rook, bishop. Bishop. Okay, so you become a bishop, you bishop, and then we're gonna go to the thing, and then we say, hey, so what do we put the cone at? I think the cone's 3, so bishop can become a 3. And I think we have 4 assets, right? I'm kind of running out of shapes, so we only have the queen and the knight left. So we need to come up with 2 more shapes. 4 shapes. So in here, what other shapes are there? So let shape shape equal mesh mesh new from shapes Bevy shape math shape. Nope. Where do you come from? So it is math. Primitives. And yours? Also known as a ring. Okay. Is that 3-dimensional? Circle, cone, cuboid, ellipse, line, plane, rectangle, rhombus, sphere, torus. That's the 3-dimensional one. Inner radius 0.4, 0.8. Yeah, torus. That's going to be the queen for sure. So we do have 4 shapes. So I'm going to do queen last, so it's going to be something and then torus. Now we have to come up with some other shape, which is annoying. What other primitives do we have access to? So I'm pretty sure this is 2-dimensional, so that's not going to help. Triangle? Let's go with the triangle 3D. That's like a point of triangle. Prism? No. Pyramid? Nope. What else? What other shape is there? There's an arc, circle, cone. I guess we'll just make you a capsule. Okay. So, radius of 0.8 and a length of 0. Oh, we have to make you slightly smaller, don't we? Radius is 0.4. And with 0.4, Kind of make it smaller arm, and then this is the cap. Capsule. Capsule. Okay, so go up here and go, hey, can we go chess piece knight is... I'm gonna have to restart my ID because this is really annoying me that it's just coming up with stuff. Clone and chess piece queen is assets dot assets dot meshes 5 dot clone like so, right, and then you're unreachable. Cool. Alright, so that means every piece now has its own bit. So maybe we should spawn the rest of the pieces in and then work on the logic to move them. So again, it's going to be really, really boring because it's going to be position if is I'm pretty sure the I check. Then this is just if dimension 1 is 1 or position dot if is dimension 1 is 6, and then again all the logic is exactly the same. We just change the name of the piece because it's kind of boring. Knight. Admittedly, the movement is the interesting part of the making chess pieces, but it is kind of like queen check. If position dot no, see, right, yeah, because the queens are going everywhere, which, so we just go 3. Is it just 3? 1, 2, yeah, 3. And because there's only one queen. Depressing. I think we want to be spaced next to the queens because there's no king. To, you know. Did I not renew? No, I was being everywhere. I think that's right. Right, so that should spawn in the rest of the pieces. So let's find out what happens when we spawn in the rest of the pieces. Oh, yeah, careful dragging shit onto the 4K monitor. I need to make both my monitors 4K is what I'm learning. So we have our queen. So this empty hole is basically where the king would be on each board, but it would be interesting to have a king on every board, and you got to keep every king safe, but is that an interesting concept to have to keep every king safe? I don't know, because we'd have to actually make the chess game and then like play it to find out if it's really fucking hard to not just check the king all the time. But that would be an interesting concept because person I was discussing this with who actually plays chess like really well, like they're like fucking really high ranked chess player, was going, the issue would be how do you trap the king, because checkmate's going to be really hard, because instead of having to close off potentially 8 places that the king can move to, as soon as you go to 3 dimensionals, now you've got 26 places that the king can move to, and then when you go to 4 dimensional, now you've got 80 places that the king can move to. So it's like, well, how do you trap the king, because you can move so much? It's like, well, what if you had to keep like I guess in 4 dimensions, actually what would it be? So you'd have 2. So So you'd have one king in one dimensional. See, the thing is you have one king in one dimensional, two kings, one king in two dimensional, and then you have 8 kings in 3 dimensional, which is like, but that's not how chess works. That's why I think you want only one king, because it's about making it generic across all of them. But anyway, so that would be like 8 kings, and then you'd have to defend 16 king. No, you'd have 64 kings to defend in 4-dimensional space. So like, even though the king can move, it amounts to 10 times as much, you have 64 times as many of them to defend. I feel like it would probably result in a lot of like, you move a piece here and then suddenly you're fucking one of your kings gets sniped from across the map. So you can't move, you can't move, you can't move, you can't move. Yeah, okay, not implemented, knight not implemented. So, and then once I've got all the movement working, maybe I should implement turns, but I still feel like moving them around is important, like without being limited by whose turn it is. But I think I might work on pieces maybe. So let's add the bishop and the knight movement. Okay. The knight's going to be interesting to do. Okay, so we're going to say chess, piece, so bishop. Now, how do we increment the bishop? See, the hard thing about the bishop is that there's no reason, because I need the pointy arrow. The thing with the bishop is there's no reason you can't move in multiple axes in cross-action pattern, if that makes sense. So I think what I could do is I could just be like, hey, increment all axes by 1. But it's like, but that means that this will increment all by 1, but this increments 1 and decrements the other. So it's like, it needs to be able to do both. And then in 3 dimensions, it gets even more complicated because you're not just incrementing, decrementing. You're incrementing, decrementing, increment, decrement, increment. So you basically every combination thereof. So I need to come up with some kind of way of basically checking every combination thereof. So how would you make an iterator for that? So really, I feel like I need to move these iterators into their own thing. They're getting a bit complicated. Might just make a module for that now and work from there. We'll move all the other stuff later. I should also commit this stuff. Okay, so let's commit this to added what do we do? Rook and king movement. Okay, so move iterators. So save this please. Yeah, okay. So move iterators. So what we need is this is going to be a struct bishop move iterator. Now, ironically, this is going to be an iterator that returns iterators. So we need like a struct diagonal. So then we need to, so you need to be pub. You also need to be pub because we're going to use you anyway. Okay, yeah, you can get the spelling. Okay, so we're going to go impl iterator for bishop move iterator, and then this is going to return a type item diagonal iterator. Right, and then fn next, and next is just going to be to do, because we haven't actually worked out how we're going to do this yet. So I'm thinking a diagonal iterator is going to need to keep track of So something like maybe well, so it needs its current, which is just a position, and then it needs a I guess a move set, which is then going to be a vec of maybe booleans. That's the thing, is do we let them not move? I think the answer is no, because otherwise they could move in straight lines. And I feel like artificially implementing a you must move in n-dimensional, like the thing of like you need to move in at least 2 is like, or then you artificially limiting it. The other option would be to have different types of bishops that like one bishop can move in 2 dimensions, one bishop can move in 3 dimensions, but they have to always move in their bishop count number of dimensions. That'd be a cool way to like give you lots of different pieces that can all move differently. But you know, so the way I'm thinking it's going to work is we need to come up with some kind of way of I guess it's just binary counting, isn't it? That's ironic. How many dimensions do we have? That would put a hard cap on my dimensions. I was thinking, no, because it's binary counting, which means that as we iterate through the iterators, we just add 1, and then by reading which bit we can, if it's positive we increment, if it's negative we decrement, and then we increment by 1, and then do the same thing again. So you just do the same thing, but we're just holding a vector of bools instead. So we're going to go full diagonal iter. I don't know, we're going to implement, well, yeah, diagonal iter. We're gonna, so this is going to return dimensions. No, and then this is the use size, and then we're going to return stellar. We're going to say, hey, you just say diagonal iterator current, which is 0 by dimensions, and moves, which is I guess it's false by dimensions, right? So that's the 0 iterator. Oh no, it's a vec. Like that. And then vec. Okay. Right. So that's how you make like an empty one. Like that's the 0 position. Right, then we need to like impl iterator for diagonal iterator, and then we say so type item is position, and then we say and then next. So here's the issue. How do I keep track of how many I've actually done? I feel like the diagonal iterator needs to just like runs into the real issue of it doesn't, like, unlike the others where I can like check to make sure a piece is still, you know, validly in bounds. This one is like, we're just gonna put out a blast through. So I mean, maybe you just say I do want it to have a distance. Distance, which is then going to be a U8, and then we're going to say step, which is also a U8. We're going to say, hey, and your step is 0. Okay, so first things first. Oh, let's move that over here. That's interesting. Why did my code decide, concerningly, that I need to reauth myself? Well, they took me back here. That's concerning. Well, what have I done? What did I break?
Well, it seems to have saved the token, so let's just go with a quick restart. Restart the code and go hello. Please, for the love of God, get onto the other window. Then we do F5 to find the current, and okay, interesting. Well, I don't know why my code decided it needed to be reauthed so that it could keep renaming the fucking stream. But anyway, the code is so buggy. I'm gonna keep working on it though, because it's actually kind of a really cool concept of being able to like. I've been watching too much Dog stuff, and I'm like, it'd be really cool to be able to interact with Twitch chat or like with chat, on YouTube, in like a really interesting way of like letting them do stuff and like that. Like, apparently, I could like let you guys insert ad breaks if I wanted to. Like, just someone could just type ad and it just plays an ad. Like, that's just a thing that I can do. And I think it'd be really funny to either let you guys play the chess game while I'm developing and like have it in the corner of the stream or something. And so you guys could like type moves into the chat, or so it's just dumb shit like that. It would be really funny to me to like conceptually to like to implement and have it like do stuff. I don't know how well it will work in terms of the limit on the amount of stuff that you can do is kind of low, at least when it comes to re-interacting with YouTube. Like, I can only rename the stream like 200 times in a day. I think that's how that works. 10,000 divided by 50. Yeah, so I'm going to rename the stream 200 times in a day, which, you know, if I'm renaming every 10 minutes, it's fine. That's like every 33 hours before I run out of quota. But the limitation is anytime I'm doing anything like reading what chat's talking about like that, it all takes 1 point, which means that like I can't read chat continuously. I don't read, like ping it every minute or so, because otherwise I would very quickly like actually do some math at 10,000. If I did it every second, I could do it for 160 minutes. Wait, should we do it by 60? So I'm going to do it for like 2.5 hours if I was pinging it every minute. So I'd actually have to like really slow down. And that doesn't seem right. 10,000 divided by 60. Yeah, okay, so we're going to need... So you don't need to do it for like 3 hours stream before you ran out of quota if you're pinging every minute. Good sign. Why did the stream disconnect? And it's back. Okay. Weird. Oh, my bandwidth's low. I'm dropping like every frame. Oh no. Oh, maybe there's a cloud in the sky. Fuck knows what happened to my stream. Alright. So we return none if the distance is greater than the distance. Next we go self.step plus equals 1. And then we say for dim slash star in self.moveset.iter.enumerate. Right, and then we can just make a record of that. So we do this, we do this, and we say, hey, so if the self.current dot inc in place dim else self.current dot deck in place dim, like that. So first off we need to go left out equal self dot current clone. Okay, like that. Then we can do that. And then we say sum out. So that should allow me to increment, basically, so if it's all false, negative, no direction. So then next, okay, so you're a bishop move iterator, which means because you iterate bishop moves, you are just going to say separate, because that's as far as a bishop can move. The diagonal, I want it to be reusable for, like, you know, if you want to step not quite full steps and stuff like that. So I also need you to be public. Right. Next, we need to be like pop struct. Oh no, impl bishop move iterator, and then we say a new So you just return a bishop move iterator, and just like bishop move iterator, not like that. So right, so you need something to keep track of like which bishop move you are. So I'm thinking you probably just keep track of a move set, I guess. So you like move set. It's just going to be a vec of moves, like so, and then the issue is I feel like it grows kind of exponentially a bit here. I'm trying to think in my head, is that actually how a bishop's number of moves grow? Yes, because technically it has to move in every dimension. But like again, every time you add a dimension, you've exponentially, you've doubled the number of possible combinations of dimensions it can move through, positive, negative versions. Anyway, so then you would, yeah, so new just starts with them all being false, and I don't know about 7 dimensions. Right, so you need to specify how many dimensions. Okay, and then so when we say next on you, we need to say let out equal diagonal iterator that has a current equal to position. Oh, actually, we'll just make one of these pub with move set. And we say move. We'll call it set, and then that set is just going to be a vector of booleans, like so. And then we just say it's exactly the same thing. It's just this except you start with set and set.length. And you return diagonal iterator distance. Okay. Right. I also feel like here. Oh, we already did that step distance. Okay, I was going to say I would need to tweak that, but it's correct. All right. So then your out is going to be with moveset and self.moveset clone. Okay. Right. So, question becomes, I think you just need to be done, like just done bool. Okay, so next we need to go for move in self dot move. No, so for move in it's something like 0 dot dot self dot move that dot length minus 1 if move if self dot move set move so if the value is true, then self dot move equals false. Self dot move plus 1 equals true. That doesn't seem right because that could overwrite the next true. I think we need to go the other way. Maybe? I don't know. So what's the best way to do this without fucking having to spend ages doing recursion? I mean, the cheatiest way of doing it would just be the same mood set, and then we'd just be like U64. I said U64, please. So then U equal we're just gonna, I think U, we're gonna say gen move set. This is boringly cheaty, but we're gonna say you take in a set which is a U64 and you return a vector of booleans like so, and then we say that we need a size. And which is the uses. So we say let out equal vec false length, and then we say for I in I out equals set ampersand 1 shifted I does not equal 0. Well, it caught on. So then we say, hey, can we say I guess we may as well just make it take in self then. Which is also a U size, like so. So then we say then so gen you take in self, and then this is self dot move set. You do that. I guess we don't need this either. We can say self dot len like that. Then you're here and you say, hey, self dot gen move set. So we make U, and then we go self dot move set plus equals 1. And then we say sum out like that, and then we just need to make it possible. So first dot len its dimensions, and I don't think we actually need done anymore, because we can just say if move set is greater than 1 shifted len, return none. I think that's correct, because the idea is if it's maybe so I want to say that's correct, because we say move set and we shift it by 1. Basically it's saying, like, if we have 2 dimensions, we need a value of 4, which would be 1 shifted 2 if it's greater than 4. I think it's greater than or equal to we want to return, because we increment it here, but we still return the iterator even after we've incremented it. So I think it's greater than or equal to. something like that, and then we can say, hey, you don't need a done, because your done is literally just the fact that your dimension moveset is 0. Okay, so you would return the 0 iterator, and then you'd increment by 1, and then you'd return the 1 iterator, increment by 1. And so when you and so then you would get the 4th iterator. You'd return this. In your 4th iteration, you return the 3 iterator, which would be up, and then you would increment yourself to 4, and then so 1 shifted by 2 is 4, and then so then you'd be greater than or equal to 4, and you would return none from then on. Okay, so I think that should be right. What are you saying? I used as index. Yeah, but like, I don't. What do you want me to do? That's very confusing. I don't. Okay, so the bishop move iterator. Okay. So, since oh god, I'm cracking myself up. Since bishops are so complicated in their movement, it's like, hey, we got an iterator that generates the iterator that generate its movement. All right. So, way this is going to work is we're going to go 4 diagonal. In bishop move iterator new with how many dimensions? So we'll just dimension numbers of dimensions. We're going to say for pos in diagonal dot with offset position if pos equals position continue. I feel like I need to fix that so that like we just don't generate the first position, because yeah. I also feel like with offset we might want to just like tweak with offset ever so slightly, because I'm pretty sure with offset just adds them together. Alright, like when you iterate with offset, like you just add self.base. So could I be extra cheeky and be like, hey, like maybe just take in a reference to a position, right? And so with offset, no, don't add the clone. We want with offset, wherever the hell that is. That's the trait with offset iterator. I want offset iterator to also take in like a, use like an A, and to say like, hey, you're just a reference to a position. Because like in theory, unless you directly need it, right, like that, then like we don't need to clone it around all over the place, which means that we can just say, hey, like just take that. Now I'm assuming these other ones are going to be yelling at me because yeah, we're cloning next, but we can just like, hey, just take a reference to next. Again, in future, if I ever do make it not a vector, then it like wouldn't be a problem because it's a tiny bit of memory, and it might actually be faster to pass it around than to clone it around. But the idea is that at the moment I'm kind of parsing a lot of stuff around, like cloning a lot of stuff that doesn't need to be cloned. So we have a diagonal, and we say, hey, so the bishop, and grab the next bishop's move, and then for the position in diagonal with offset position, right? And then we say if position is not equal to position, okay. And then so there's something about how rooks worked. So we say if this. So this should check each diagonal individually. So we say, hey, let if other board. I guess technically we could rename this to next so that it just works next. Okay, so board.get next, and then piece.get other, and then so if they're not the same team, then add the move and break out of this, because that's the end of this offset. Yep, so break out of there. Otherwise, add the move. Right, and then you get to here. I mean, that in theory, they should be all the bishop moves, because the bishops. We went about it away. I mean, well, we got an error somewhere. Where though? I don't see any. It must be in king, maybe. Yeah. Offset position. Let deck equal position dot decal, and then reference to deck. Right, that should work. And then these don't need that because they're already referenced. Right. Let me run this. There you go. Okay. Okay. So we were doing rook, which apparently can't move because it's got pawns in front of it. So we're gonna move, and then and then we're just gonna get you eaten by this pawn. This pawn. Oh fuck! Wrong one. Oop. So. Is that a rook that I clicked on? Well, apparently it's a rook. The answer is apparently it can't move either, because I fucked something up. Okay, so I guess the first thing to check is, are we actually getting any moves put here? So first things first, print line. So something like next. Alright, so first thing to check is, are we actually getting a sequence of moves? I'm also going to maybe like stop it from printing out which piece I clicked on. I clicked. Yeah, can you stop telling me what I clicked on? Thank you. So the question becomes, right, when I click you do try an awful lot of pieces. You apparently are not working properly because you shouldn't be returning. Are you hitting yourself again? Is this that we really shouldn't be checking the immediate piece below you? Now, obviously shouldn't be checking the piece immediately below you. Hiding a lifetime there. Confusing, so the same motive. I don't know what you're complaining about. That's what you're complaining. Anyway, I don't get it. Yeah. So it's move iterated. Something in here is doing something. So what's happening is that. So, well, it appears that we're trying this position and it's failing, and when we're trying that position, it's not failing. The next is apparently not equal to position, maybe, I don't know, and then it's finding itself. I'm sure this is what we had happen before. So we need to go back to piece, wherever it was. There we go. Where the hell is our moving the bishop? So my bet is if I said, well, the obvious thing is that we just move it to the other side. So that's where we should be clearing that stuff out. But it should definitely be trying a hell of a lot more pieces than that. So it's only got 2 directions that it actually tried. Interesting. Right. No, obviously, because it can't move in this. I moved that pawn out of the way, but that's not where it's trying to move. It's trying to move here. Here, maybe? The answer is apparently no. The fuck is that? Right, so
That's diagonally up one. So is it here? No, it wouldn't be there. Be here. Is that where it's trying to move? It is. Okay. And then does that free up a lot more space, because I assume that once we've moved through that pawn, wherever that pawn was, so it moves through here, which is diagonally one that way. So then the next one would be here, and then the next one would be like here, and then here, like here. Okay. Then we can take a pawn. Where's the pawn we can take? Oh no, we have to find the. Where is it? Somewhere on this level. Yeah. So it's going to be. Wait, maybe not, because we're moving from that corner. Wait, can we not take a pawn? We can't, because the next step. I think we're stepping. Yeah, we're stepping this way, which means we stepped to here, which means that when we go up. I need to make that much easier to see, to be honest. I mean, does that make sense? Can a normal rook not take? Wait, there's got to be a pawn around here that you can take now. Surely. I see pieces. Yes, you can take this one. It's very confusing about where a piece can move. And this is sort of it. Because we force it to move in every dimension, it's not nearly as powerful as you would think it is, because that rook, despite being like very, very much touching a lot of pieces, is like I am awfully screwed in that I can only go over here, or over here, or over here, or over here. Like it can't touch anything near it. And my question becomes, so you're the horse, so we haven't actually implemented you yet. You can't touch it. You can't touch it because you're also a rook. The queen obviously can't touch it because it's a queen. And it's like surrounded. I'm curious if it's actually in very much danger being there, because like obviously the pawns can't move. Pawns might actually be really powerful in this because of the fact that they can move on a singular dimensional plane, but like jump on any other. So it's like it's going to be quite common for like a rook not to be able, a bishop to not be able to get them, but the pawn to be able to get the bishop. Is that a common thing that happens in regular chess? Well, theoretically not, because if a pawn can jump on a bishop, then the bishop can jump on the pawn because they're diagonal. Anyway, so the thought is like, is that actually how that works? Is yeah, your bishop can't take a pawn from its starting position. It ended up here, on a miles away chessboard, but it ended up here, and then it jumped to here, and then ironically it couldn't take either of these because it ended up on the floor above or below. Like it can take the pieces, just not on the. Actually, it can take them here, just not on the platform that it's on. That's fun. Okay, so interesting. So I think that like, the knight might be the next piece to try and work out. The thing with the knight, in my humble opinion, is that the knight runs into the issue of like, do you do the same thing we did with the bishop, where we enforce the movement rule, which then again caps the knight at being able to move only in like up to 7-dimensional chess, because it literally cannot move without having to move the entire length of the board. I also don't think you could do it that it could move in the same dimension twice, so you'd lose the ability to be like, can we go further by zigzagging the knight back and forth across its own path in time and space. So how do we do the knight? The real question, isn't it? Okay, so all right, let's actually commit this because we're getting working. So added could be written here somewhere. Pieces, bishop move. Okay.
So, so this next is chess piece knight. And again, for actually, let's not do that. So we're going to go to our move iterators. So this may need to be broken up even further. So we're going to move iterators, and then we're going to go, hey, can we mod bishop, right? Then we're going to have mod primitive. Right. So we're going to go to our bishop. We're going to go, hey, all this is bishop move shit. Right. And then this is primitive shit because this is diagonal iterators. So we have to first off use super. So that should fix that. Same with you. I need you to use super like that. Thank you. And then interestingly, okay, no, you are still broken. Okay, so then we're going to say pub use primitive diagonal iterator and pub use primitive, not primitive, bishop iterator. Okay, that should fix all those because now they're this. I don't know what you're complaining about. And then new is never used. So next we're gonna go mod make knight. Right. So we need to come up with how we're gonna make a knight. So we're gonna go struct. I think I'm pretty sure the knight we just want to move him as an iterator, but maybe not because we might literally run into the issue of like Personally, I think this is like one of the few places that I'd want to deviate from regular chess, and I want to say that the knight can just do a single step move. Like a knight can either move 1, or it can move 1 and 2, or he can move 1 and 2 or 3. But that differs from normal chess, because in normal chess a knight cannot move only 1. So how do you encode that it can only move? So I'm thinking we want a knight move iterator that has like dimensions, which is use size. Something like that. So we look at the number of dimensions that it's moving, and then we want to maybe we should go with an L move iterator. Oh, this would be a knight move iterator, and then the knight move iterator does nothing right now. So we would want to go to primitives, and we would got to go here, and we like struct L move iter, and we want to go dimensions, and then that would be a use size. See, the trick is how do I come up with like a list, a way of being like these are all the possible, because I'm pretty sure if we go back to our chess game, stepping 1 and 2 is the same as stepping 2 and 1. The order doesn't matter, but stepping 2 and 1 is different to stepping. So the question is stepping 1 and 2 1 and 2 and and 1 and 2. The other knight here, so it would be the knight can move to here, 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 here. So I think from here it's steps 1 in every dimension, and then he has to step 2 in every other dimension. So from here he steps here, he goes there. So he steps here, he goes here, he goes here. So the question is, so I think it only needs to go one way. So you step 1 and you step 1. And you step 1 and you step 1, you step 1, you step 1, you step 1, and you step 1. They always go clockwise. We don't get every dimension, do we? So we only got there, 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 and there. But if we then step 1 and so we got that one, got that one, got that one, got that one, got that one. So we can't get to that one. So how do we get to that one? See, but I don't think I can go here, there, there, because if I did that, then if I went here, I'll go there, there. Well, there's 1, 2, 3, 4, 5, 6, 7, 8 places he can move to, and 4 moves, so there must be 4, and then there's 2. So he goes, step here, go positive, negative. Step here, go positive, negative. Step here, go positive, negative. Okay. So how does that math? How does that math? How does that math? So how does the L dimension work? Which fucking thing am I opening? This one. So if we say that we have that many dimensions, what we need to do is we need to somehow iterate through one step in each dimension for 1 step, then each additional dimension for 2 steps, and then each dimension after that for 3 steps, and so on up to dimension size. Up to dimensions. I feel like the horse is going to have the greatest movement in the entire game because the horse is like just able to do that kind of shit. Okay, so this is the dimensions is the top, and then we need to go. So you're stepping in how many dimensions? I want to say like steps, which is also because we didn't say that there are 7 dimensions and we're taking 3 steps. And then how does that work? So we need to say something like last. And then would last be a vector of view sizes, maybe? See, because we need to say step 1 in dimension 0, and then step 2 in every dimension other than dimension 0, plus and minus. And then we need to step, so we would need to say, so we need to step 1 in every dimension, then we need to step 1 in every, step 2 in every other dimension, then step 3 in every dimension after that, until we reach steps count. And I think we need to force it to make steps, to take steps, which actually ironically means we could probably just go with last length, because then we can call multiple iterators. We can say like an L move 1 iterator
takes 2 steps, and an L move 2 iterator takes 2. And in theory, we could go all the way up to 7 because 7 is the Right, because we don't need to go up beyond 7 because there's no way to move more than 7 in a single step, unless we make the to be able to like fucking wrap around the board. Fucking dumb. It would make that positioning really hard to guess. And I also feel like eventually, like when you get to like 100 DHS, it may actually just be able to get literally anywhere because it'll just eventually every combination of pieces will move somewhere. So first off, we need to be like impl L move. No. So we need to say it takes in dimensions and steps, which is the U size, and steps, which is the U size. And returns a L move iterator. Okay, and then L move iterator. So dimensions is dimensions, and steps is steps, and last is vec 0 by steps, and then we want to go maybe ink is false. True. Okay, so that generates that, and then we need to impl Almo for iterator. Wait, what? Other way. Iterator for Almo. And then next needs to do whatever next does to do. Right, and then item is just a position. Right, so what I want to do now is when I go back to pieces and when I go back to here, I want to say, hey, knight. Say for next in L move. Okay, so we need to make sure that we actually include that as use L primitive L move. Okay. Thank you, public. So, pub. Okay. So L move iterator. So we go here and we say, hey, L move iterator. New. And so it's going to have a little dimensions, because we already know dimensions, and then steps is going to be 2. So we can just basically work out exactly what it's going to look like, and then we're just going to say move stop push next. The idea being that whenever I click on a knight, it's just going to show me every possible move the knight can make without any discrimination on whether the knight should be able to make these moves. We need to go like dot with offset position. Okay, so from where the knight is, obviously. So we should probably fix it so it won't immediately crash. So it's going to immediately crash because it's got to do. So how do we work this out? So. So we're going to go something like for I in 0 dot self dot steps. Right. So I mean, technically it should probably be like 1 plus 1, so we're not constantly adding the 1 later.
So that's an interesting point, isn't it? Maybe it shouldn't be U size. I feel like last needs to keep track of more than just that. Okay, so what do we want to return? So for this, what we need to do is we kind of do need to know if we incremented or decremented the dimension. We do need to know if we incremented or decremented the dimension. So first thing we do. So we need to be like let nude position. We call it out because it's consistent. Equals position vec 0, comma okay, no, we do need this to be 0 and 1 because we actually need to use it to implement. Okay, so we need this to be this and this self.steps. No dimensions. So we need to return that. That's our size. Right. And then for this, we need to say let dim equals self.last I. Right. So here's the issue, is we need to be able to go ink deck, ink deck, ink deck, deck, ink. Because we need to be able to go, to be able to move 3, we need to be able to go ink deck, ink deck, ink deck, deck. Okay, so we do need to keep track of that, which means that we should probably get rid of this here and replace it with I size like that. And then we get rid of this. We say 0. So the issue with that is now we have that the 0th dimension can't represent positive or negative. So it does mean that we're going to need to go somehow offsetting the dimension. Okay, so we need to get the last, which is going to give us that dimension. So we're going to say ink let pos equal dim dot signum 1 if the number is positive. Yes. Okay, so we get the signum. Okay, and we need to kind of assert that so we then need to say let dim equal dim dot unsigned absolute. Okay, so this will get us the dimension number -1. So that should get us our dimension number back. So now this could be an issue because we're starting at 0, and starting at 0 implies that we're kind of actually starting in an invalid state. So okay, so how do I do this? So 4i, 9 steps into, okay, so I kind of want to do something along the lines of go with the positives first. So we go if dim equals 0, dim equals wow. I guess the thing with that is we would just want to go like let start new start equals 1 dot steps plus 1 dot collect into a vector. That should work to mean that we never start an invalid state, because we always start with just every dimension incremented by 1. Sure. By 1. I size. Oh. Right, so, I mean, why not just put that right here. Okay, so we start from dimension 1, steps, the size steps plus 1, collect. Okay, so then we say, hey, like the dimension last, get the positive negative dimension, and then we say to get the absolute of the dimension minus 1, because it's saying that dimension 1 is the one is 1, but when we store it, it's actually 0. Then we say step. Okay, so we then want to say that out dot set no dot. What was the way? I had a way of setting a specific position. Add dimension. Right, and okay. Well, we could just say dimension dim equals either I plus 1 I as my size plus 1 times my odds. Okay, wait, I as my 8. So we did probably want to debug assert steps is less than 7. No, less than 8 maybe. Then we return sum out. As I8. So we take 1 further than the step, because obviously we don't want to step by 0 times by the positive or negative value. So how does that work? So if we have a 1 in there, we have the value 1, we will step. So in position 0 we have the value 1, we will step by 1. If we have position -1, we'll step by -1 in that specific dimension, in the dimension that's in the corresponding step position. So this is the step position. Look at that. This seems somewhat correct. Cannot move. 0. Okay, so I think that works. That should make our output, right? And then when we get to here, we need to go, hey, so how do we increment through each of these? So I guess the way to do it would be to go
So at the moment, we've currently stepped taken one step in like dimension 1, 2, and 3. So then we want to go and increment 3 to 4. So what we want to do is say like okay, so we want to increment all of the tailing dimensions first, I think. So we want to do something like for I 0 dot self dot steps, and then we want to go dot reverse. So now we're going to stepping through it backwards. I'm going to say so it's going to be something like self dot steps I. So if self dot steps I is less than 0, self dot steps plus minus equals 1. Right, else self dot steps or else self dots not steps. No, wait, how many last? Self dot last I minus equals 1, and then last I plus equals 1. Okay, then we're going to say if this is going to be really inefficient, but it's like I need to write it this way because I can't mentally project far enough ahead to work out exactly what it should be. So if last I equals is greater than or equal to dimensions, self dot dimensions, then self dot last I equals it's going to be -1. Oh, come on. It's going to be equals negative I equals negative self dot last time minus 1. I think it's then minus 1 again. Right? I think that's how that works. not entirely sure, because it's in my head. What are we doing? What we're doing is we're going through each dimension in reverse, and we're going, hey, if you're less than 0, which means you're in the negative range, subtract 1. And if you're more than, well, you should never be 0, so, but if you're in the positive range, we're going to add 1. And then we're going to say, hey, if you're currently the highest dimension, like if your current value, positive, is the highest dimension, then we're going to set you to the negative version of 1 dimension higher than the one below. So the idea is that we will go through all of the positive dimensions up to the cap. We will then go through all the negative dimensions down to the cap. Right. Else is self dot last I, not UI, is less than or equal to self negative self dot dimensions. That is size. Right. If else if self dot last I is less than or equal to negative self dimensions as eyes. Okay. Else if self dot last I is less than okay. So if you're too negative, then we need to go. So once you've gone all the way to the bottom, we say what if we actually incremented last instead? Yeah, I think that makes much more sense. Is we want to say something like if let some last equals self dot last dot last mute else panic empty when question mark. Right, so we want to say when we get to here is if last is less than 0, dereference last minus 1, else dereference last plus equals 1. Right, so what we're saying is if the last number is negative, subtract. If it's positive, add 1. Right. So then when we get to here, we say, hey, step through and go. So we don't need this because that would decrement each piece by 1, each dimension. So we only say if the last, if I is greater than the dimensions, then set I equal to the last dimension, the previous dimension in the list, minus 1. Right, so basically if it gets too big, set it to the negative version of itself, which is going to be 1 smaller, which technically is 1 bigger, 1 dimension above the previous dimension. And then else if last is basically the smallest version of said self, right? If negative version of said self, then we want to say that we need to say something like if self dot last I minus 1 is less than 0, then self dot last I minus 1 minus equals 1, else self dot last I 1 plus equals 1. Right, so
But then what do you so you say, hey, like if I go to negative, so basically if I go off the cap on the bottom, I want to modify this, and then I want to do the same thing, except well, what if this is negative? You got positive. We want the negative of the absolute -1. Right, we need the negative of the absolute, because if it's negative, we still want you to become positive. We just want you to become the version of that dimension. So then when we come down here, we say, hey, so same thing happens. So if you become too negative, we want you to decrement the number below you or increment the number below you, basically change it to the next dimension in its dimensional path. Now, concerningly, it may, in fact, if you get too big, become the negative version. I feel like this is possible to end up in a state where we might end up changing a dimension below us, and then that dimension then steps itself up into being the same as us. So then we're going to do a lot of recursive, a lot of redundant logic. So what we're going to do is we're going to say, hey, so you check yourself, and then say, hey, if yourself, okay, and then we're going to set our self. So this is us becoming negative. So we're going to say if self dot last less than 0 is, and then we want to say we want to set our self dot last I equals self dot last I minus 1 dot absolute plus 1. Right, so that should, in theory, so when we decrement the one below us, we then set ourselves, and we're also going to say that, hey, you actually increment from 1 to step size, meaning you don't do the 0th dimension, because the 0th dimension is getting changed by this, and eventually the 0th dimension will equal that, and then we need to go somewhere here and be like, if last self dot last 0 dot absolute value wait is less than 0, is less than dimensions, self dot dimensions. So there's, say, 7 dimensions, and we're doing 3 steps. So minus self dot steps. Right. So if you're less than 7 dimensions minus 3 steps, if you're less than -4. What if we said 3 minus 7? I think we flip that around and we automatically get it. Step minus self dot dimensions. Return 0. None. This seems complicated. So the idea of this bit here. I'm gonna make an I32. I'm just gonna cast it here. Here's dimension. I size. Wait. God damn it. Sure. Also I size. Also then become steps as I, and as I size. Right. So Useless. Right, why can't we increment by I? Because, okay, so no, you stay useless, you bastard. Mostly because I don't want to cast shit around. Alright, so, yep, cool. You're telling me I don't have to do that anymore. Okay, so this bit here is checking basically to say, like, if the first number is low enough, then we've checked the negative direction of all dimensions far enough that we should be done. Now, the question is this actually going to fucking work? Who goddamn knows? This is very complicated, and I'm unsure if this is actually going to work. So we're going to go back to our pieces here. I'm going to go, hey, so what we're checking, we're just checking, hey, the knight with a step of 2 and a dimension of 7. So the knight, in theory, with a step of 2, we click the knight, well, apparently we crash, because we indexed in, the len is 5, but the index is 5. First off. So, out. How did you get to a dimension of 5 then? Apparently we're doing 5 dimensions. We're doing a step of 2. So, can I get you to please print? It obviously did a lot of checks, I assume. I don't know, maybe it didn't. So we need to print out self dot step as I32 as I size minus self dot dimensions. The question is, did this ever reach first dimension? When I click you, what do you crash? So you said negative, so it just never let you -3, so it's always -3. So we're waiting until it gets to -3. Now, the question is, how did you get to 6? What set you to 6? Right, because it's here, it's unsigned. So we need to go something maybe like print line set to, which is going to be set I to, I think we need to be adding 1 somewhere, maybe, who knows, set that to self dot last I, right, and then you need to be set I minus 1. Well, we do it to either of them, so set I minus 1 to I minus 1. So and you also set I to, I think that I minus 1 plus 1 might be plus, so you are I minus, right, so let's run that and see where this gets to, and why the hell, and when it crashes, what does it do on the previous iteration, basically. So when I click you set 0 to 5, which is, I guess, somewhere up here. So it's going to be in here. Set 0 to 5. Negative, yeah. So you set 0 to 5. Right. And then you set yourself to 6. Now, the issue with this is that if this gets incremented, right, so we go through and we go, hey, set this to this. What we need to check then, I guess, is if self dot last I minus 1
dot absolute is greater than or equal to dimensions. Else do this, and the idea is that we actually want to set u to minus, this might crash on its own, but +2. The idea is we should never be able to get here because this should kick in before this gets to proc. The idea is that if that dimension is going to be refreshed, then we want to check dimension 2 below. So you set 0 to 2, 1 to 3, and then 1 to -3, and then 0 to 3, and 1 to 4, and 1 to -4, and 0 to 4, and 1 to 5, and then 1 to -5, and 0 to 5. And why did it crash? Attempted to subtract with overflow. Right. So like ampersand self dot dimension. No, it's I is greater than 1. No, I is greater than 1, which means it's at least 2, which means we will be grabbing from 0. So that will at least avoid the subtract with overflow or with underflow. Probably still won't work. No, because it still sets that. Okay. Now, we don't decrement by amount, we just set it to an amount. So it's possible that we can say if dim is greater than or equal to self.dimensions, called self.next, because that should as I30 as users. So my thinking here, which this is either going to stack overflow, it's going to work, is that we're basically going, hey, like if we end up in a state where the dimensions are wrong, just like do another loop and it should catch it. It just printed -3 a lot, and then the stack overflowed. So what that's saying, with a lot of it's did it just like never get there? Okay, so got to here, got to here, got to here. So so first up, we should probably get rid of this bit here. We should just always be doing this, because theoretically that's where we went wrong, is that every loop should be able to fix itself. Nope, it still doesn't. It just gets stuck at -3. But why? Is it because it tries to do that first? Yeah, probably. So it's getting to here. So what we need to do is probably something along the lines of well, see, the idea is we need to run this logic first. We just need to make sure that we grab out the last equals self dot last dot clone, and then we go down here and we say this instead of self dot last is just last, I think. Well, we could probably just give it last. No, can't do that. Yeah. So the thinking being that if we grab our last here, then we have our state for generating our thing. Then we increment everything, because what was happening before is we were trying to work out what it should be, then incrementing everything. And it's like, well, that doesn't work, because once you get stuck in that loop, you're stuck in that loop. Well, it's still didn't fucking work. It just got really, really big. Why are you like this? Set 0 to 367. Set 1. Why? Why do you never get set to a negative number is my next question. Right, because we never actually do 0. Alright, so we'll iterate from here to here, because that's when you actually do your little flippy flip. Now, the issue is, if your dimension is greater than the issue is that you're trying to check what the dimension below you is. So we just kind of need to be like, do all this, but then we're going to go like, so skip 1. And do all this, and then we need to say something explicit for 1, and we go like, if self.last 0 is greater than or equal to self dot dimensions, then self dot last 0 equals -1. But that should fix that issue of it just running until it overflows, because now it will at least fucking catch it. Okay. So apparently very much incorrect, because like surely if I just click a knight, the knight should move. Oh wait, we give it 3 steps. We give it to pieces. No, we give it 2 steps. So why the hell? So 1, 2. But why are you not getting 1, 2? Why can't you move there? Why is that not a valid move for you? 1. That's 1, 2. So why do you never step to here? Why do you never check? So say you to 2, and then say you 3, and then say to 4, and then say to 5, and then why did you go to -2? Okay, maybe we need to go through them in the correct order then. So what have we said? We go from 0 to self dot steps. We don't reverse them. Start the whole fucking thing in. So what we do is we increment the last dimension like so. Let's get rid of this bit. Get rid of this bit. There you go, okay. So we say each dimension needs to check if the dimension above it has rolled over. that's why we need to check in reverse, is because if the dimension above you is rolled over, then you may have rolled over, which means the dimension below you means. Alright, so fine. We're going to need to rate this in reverse. So first up, we do steps -1 because we don't want the top dimension touching itself. So first thing we do is we just increment the top dimension by 1. Positive, negative, whatever. Now, we might also want to go if last is greater than or equal to dimensions, self.dimensions. But how do you know what your number was? Yeah, no, see, because you would need to know what the second to last dimension was, and that's where you start spiraling into, like, it all becomes a bit recursive. So we have to do it, make sure we have to work out how to do it in here. So we're going to skip that one. We're going to go, hey, so in theory, let's go like up. Up equals self dot step dot last I plus 1. Right, that's the up u. Right. So if up is greater than or equal to self dot dimensions, then self dot last I plus 1 equals self dot last I. So when you take the absolute value of u, because we need to reset u to the abs, so you need to set it to u plus 1, right? So now you're 1 dimension higher than this dimension, and you're minus 1, right? So basically, if up ends up like that, if up is less than or equal to negative self dot dimensions, then self dot last I if okay, so length is equal self dot last. It's just for the sake of making it readable I. Right. So then we say this dot absolute plus 1, negative this plus absolute plus 1. Okay. So then we say if up is less than or equal to this, so if this is less than 0, then self dot last I equals 1, else self dot last I plus equals 1. Right. So we're saying if up dimension, then if up's dimension is greater than negative this, so if this dimension is less than 0, increment this dimension, and then decrement this dimension. Okay, we also need to say that self dot dimension, no, self dot last I plus 1 equals self dot last by dot absolute. So positive then becomes negative. Yep. So to take the absolute of that value plus 1. Right. So we set the one above to the correct value. And I think that's all we need to do. Just need to iterate through. So the first one, we either increment decrement every time. We then, as we step down, update our self based on what the one above us is like. And then if we changed our self, if we ourselves wrapped, or if it wrapped down, we increment ourself and then reset it to our self plus 1. And that should work all the way down to the 0th position. But we probably need to also check that if right. Well, no, so you do this, and then in theory, the number below you, so you do that to yourself, and the number below you will tweak you. The issue is that could also, that's going to result in a fucking annoying loop of the number above is now going to be wrong. Anyway, let's see if this at least gets us the result we want, even if it's really slow, because it's going to end up hitting this loop a lot where it's going to be like the next number is the wrong number. Yep, no, we overflowed again. Why are we overflowing? What, like, he never gets reset? Probably fucking the bottom one, isn't it? We're probably stuck in that. Oh, no, it just printed really a lot. Okay. First up, we don't need you printing this all the time. Did I remove the debugging? Didn't I? Can I get you to print line? Oh. Oh, actually last, because that'll tell us like where we're stuck is when the values were set to what. My assumption is that the first dimension in the last is just going to keep incrementing forever. Yeah, well apparently they're all just incrementing forever. So it just never sets itself, which I guess is fine. Then we go here and we say if self dot last 0 is greater than or equal to self dot dimensions self dot last 0 equals -1. Okay, we just need a specific case for the bottom condition, because we don't, same as how we just do the top, we need to just do the bottom. Okay, and again, we're somehow missing, doing my fucking head in, why are we missing something? So you're only finding -1, 6. Which, so you can find the 2 diagonals, or you can find the 3 diagonals. You just can't find whatever this number is. Or this number, I can see. So what the fuck are you checking then? Okay, can we just get you to like print line last and be like, where are you actually fucking checking? We're checking lots of spots. So 1, 2, 1, 3, 1, 4, 1, -2, 1, -3, 1, -4. Okay, 2, 3, 2, 4, 2, -3, and 2, -4. 2, 3, 2, 2, 3, 3, 4, 3, -4. Question: why are you checking 5 when none of the others checked 5? I don't think 5's a valid option anyway. Right, and then somehow you get to 6, which is even more of a, like, that's not a thing that you're allowed to do. Interesting. Wait a second. Maybe what's going wrong is when you get to here, to set you to -1. And then for I in 1 dot dot 2 dot dot self dot steps, maybe, I don't know, and then we say self dot no, so it'll be 1 dot dot steps and then equals I plus 1. As I size. Right. So I think what's happening there is because we're inverting the when we get to that, when we step the next dimension, we don't reset the other dimension, so they just end up getting re-high. So I think that we're still gonna fucking 5 somehow. So 1 2 1 3 1 4 1 2 1 3 1 4 2 3 2 4 2 5. So then we get to 2 3 2 4 2 3 2 4 3 4 3 4. Okay, I don't know how we're getting to 4 5. Four 5 is not a valid thing for you to be. And then, for whatever reason, so you're kind of working because you are checking like all of them, but you're just missing like a bunch. Now the fact that you're missing the specific ones you're missing makes me think that it's probably to do with, to get to here, we probably need to step there and there. Yeah, because we can't step there. So we're stepping, so we're like stepping there and there. We're stepping forward and then there and there. I'm stepping here and then there and there. The issue is, what number are you fucking missing? We need to work out also why you're getting like a fucking 5. How are you actually getting a 5? Like when do you acquire a 5? When so when this dimension, so that's one thing, we need to stop this. It's not when last is greater than or equal to self dot dimensions. Because dimensions is equal to 5. So when you become, well, we still want to step. Well, I guess technically we can't step 1 and 4. We can, because stepping 1 and 4, we then need to step all the others. Wait. So it just can't be the same, like, because that feels like what it's missing, is that it's stepping. Anyway, look at that. So 4, and then we obviously can't step in 5. So how are you getting 5? So when you're equal to 4, it kind of works. We just need to, you know, not do what we're doing. So like we need to just like so step through all the others. So we step 1 2 3 1 2 3 3 4 4 4 3 4 4 4. Except when we go to 2, we can go back to 1. So it's not that we actually need to set that. We can just... It just can't be equal to any of the others. So, up this. So, if up is... Can we set you to -1? Technically, we need to check that last doesn't contain any of these numbers. But anyway, let's simplify this. So up is less than negative dimensions. So that means we need to modify this by plus minus 1. And then we need to set u to 1. Right, like that. And then we set u to -1. And we set u to 1. So to all the other dimensions. So what we want to do is when we set this to -1, we don't want to set it to -1. We want to say we just like fn find available, and that will take in a reference, like last, a reference to a vector of I sizes and dimensions. It feels like I'm doing this in just like kind of the wrong way, which is it's like a new size, I guess. And then this will return an I size. And the way this is going to work is we're just going to say for I in 0 dot dot dimensions. Let out equal 1. If dimensions is not so from, I guess it's 1. What? No, that's why. So if last dot contains I, return I. So on one dimension, I think it's dimensions plus 1. Right, because technically 5 is valid. Because we subtract 1 from it, which means in a 5-dimensional 4. Yeah. Otherwise, I guess 0. Okay, so I understand. So first off, can we just I suppose this is gonna make it so much easier just to not have to fuck around with doing this shit constantly. So, and doesn't contain last dot contains negative I, negative I. Right, and then we return I. So the ith dimension is free. So then we say to you, we go, hey, can we set you to find available self dot dimensions. Right. So I guess we need to ignore the last one. So maybe we first off don't make you a vector, make you an array. Like that, because that would allow me to say we want to skip the specific like one that you are. We want to reference to self dot. Right, so if up is greater than or equal to self dot dimensions, yeah, we can probably just say greater than, because self dot the dimensions is like we technically want one larger. So then we say that you are equal to find the next available. Which I mean ironically means it can't find itself because we haven't updated itself yet. Right. So you want to find the next available number. Right. And then except the negative version of that. Find available. Negative that version. This just doesn't, it's not computing in my head. Yeah, okay. So you always increment by 1. But something tells me I need to be like, hey, can you like find available self dot last self dot dimensions, and then here we need to be like negative find. The issue with this is we're just gonna end up scanning everything multiple, like over and over and over and over again. Right, because I'm almost certain that we need to
do something like that.
mentally I just can't quite grip it. What do I need to do? Yeah, see, it's just gonna loop forever because it's come on, please stop. Okay. It's just gonna loop forever because all it's doing is dodging the other one, so it's just probably end up with a spiral. How do I iterate through this? What if I said a vector of range of I30 size, something like that. Logos I size. And then we go. It's gonna be really slow. We're gonna be like. Let vec equals vector new, and then we say you get vec now, and then we go let dimensions equal dimensions as I size, something like that, and then we can just pass in dimensions now. Right, then we go for my in step. I don't even need the I, just for 0 dot step, and then we want to go for dimension negative dimension to dimension. I don't know if I need the +1. I think it might be like negative dimension +1 to dimension. Something like that. So then we just have the vector of those, and then we can go, hey, can we just go here and be like, do nothing for now. Okay, so you'd be like, let dimensions nudes equals this is the vector new. Okay, then we gotta go for move. Okay, we'll be like let let
first equal self dot dimension steps dot steps 0 dot next. Right. So basically, if we run out of first dimensions, then we just forever return null. So there's our iterator's done. Well, none. So then we say step for step in moves, not moves. Self dot step. Oh, I guess it'll mute maybe. Step in step. We know how many dimensions there are. So I kind of want to go like last vec. Something like that, where we store what the value is, and it's only if we get none from an iterator that we if maybe we'll just have it done. Maybe, I don't know. Not really making sense to me. Not clicking. So if self done return none. Alright. So okay, so somehow I need to say like grab the last one, increment that. So I need to be like for step in self so last is just a vec. Decided I want to validate my check my bit of code. Are you fucking having a fit? Maybe no refresh token available, you bastard. What do you... Okay, apparently we just restart the code then. There's definitely a refresh token available. Bizarre. Okay. I need to F5 then so it starts working again. Okay. So four step in self dot steps dot intermute dot reverse. Right. So starting at the end, working our way backwards, which again doesn't actually matter. We could literally have gone forward. Maybe we'll actually just go forward. So we probably want to do right. So I and then step. Right. So what we're going to do is we're going to say let sum next equals step
dot next. If and then we break. Okay. And we say self dot last I equals next. All right. So then that steps that. All right. So we set that, and and we go else self. Okay. Else dereference step equals we want to say something like if I get negative self dot dimensions plus 2 dot dimensions self dot dimensions. So what we're doing is we're trying to get the next step, and if we find it, then we just leave because we found the next step. I think. Right. Otherwise, we reset the iterator and we say self dot last I equals negative self dot dimensions plus 1. I think. No, I think it's just negative self dot dimensions. Right, like, well, no, you'd be plus 1 because we don't, because we don't want you doing redundant stuff. So because we've grabbed it here. So because if it's negative 5, that's dimension 4, but in a negative direction. All right, so we do that, and then that continues the loop because we didn't break the loop. So we reset yourself, set your value, and then we would go to the next dimension and grab it. So if they all expire in a row, we tick all of them, but otherwise we just tick the first one and then tick the second one, and tick all of the first one and then tick the second one. And then when the second one rolls over, we tick the third one and then tick. So it should tick its way all the way along. Okay, next is the annoying part. So we need to say if self dot last dot deduplicate. No. Contains. It has duplicates. No. Okay. It's got to be a way like to easily tell if it's got any duplicate pieces. Anyway, let's just put it to do so it stops yelling at me for fucking not. Right. So we break because we've set the next number. So I don't know what this move is coming from. To be honest, it was probably what I'm using last for now. I just decided that if we store it, because otherwise we end up consuming it all the time. So we get to here, we break this. So first off, I think this actually wants to start at from dimension, negative dimension to dimension. Maybe. I think the AI might have got it right because it might be to dimension plus 1. Because again, we subtract 1 off the dimension. Or we were subtracting 1 off the dimension because we use the negative dimensions to indicate negative direction. So, and then done. It's just false. Okay. So, for I step, right, in self step, enumerate, next, self dot, next, break, self, minus, self. Okay, so these should in theory keep the last list updated with the correct dimensional values. So
the key here, where it's going to be a little bit weird of a waste of time. How do we make it not do redundant work? But anyway, so what we're going to do is, because I feel like it's going to end up checking the same place twice, but that shouldn't really matter. So then we can go something like, well, leave the to do actually, because I don't want it yelling at me again. What we're going to do is we're going to go for I in 0 dot dot self dot last dot len, right, for j in 0 dot dot self dot last dot len, and then we say if I equals j, continue. Well, at this point, it's just I think that's how you do them. We don't need to, so we check all eyes, and then we only have to check the j's that are I plus 1. Right. We don't need to check that, and then we say if self dot last I dot abs equals self dot last j dot abs. Then we want to return self dot next. Now, recursive calls to itself, but that's fine. And then so we enumerate this, and we want to say, hey, if you how do I get this to not break through? That'd be interesting. So, because we only break here, what I want to know is how to get it so that I need like an outer loop. This is where I need to go to physically. So what I want to do is say, hey, like if this loop ever actually completes, the only way for this loop to complete is for the final one to have done a full lap, and so that would be done. So I guess if you ever get to here, if I equals I think that's like it's done. Like if it gets to here, if I equals steps self dot steps dot len self dot done equals, because like to get to here like that means that you've procced done, like you're resetting. Yeah, it's -1. Otherwise we can return whatever it is. So we can say let you move equals position vec 0 comma self dot dimensions, like that. So we do that, and then we go for dimension in self dot last we say let dim let pos equal dim dot is positive. I mean, sure. No,
No, it wasn't is positive. There was it's a fucking thing for it. Signal, yeah. So then we say moves dot set. All right. So we dot iter dot enumerate. Then we say, so this is the by and the dim dimension. Right. So then we say moves dot set dimension add. What the hell was it called? Something dimension. Go to position. What's it called? Add dimension. It is literally called add dimension. Add dimension, and the dimension is going to be dim, but the dim needs to be the dimension equal dim dot abs unsigned absolute minus 1, because they should all be 1 higher than there. And then we pass in dimension, and then the position times by as on. Okay. And then we return some moves as you size, and then as you as I do. So yeah, we'll fix that in a second. So if this is working as I intend, we go, hey, if you have any overlapping dimensions, if there's 2 dimensions that are the same, basically you've got a duplicate, you share a dimension, just reiterate yourself, and you should increment something that should make one of these dimensions unique. And so it just keeps doing that. And then when it doesn't have, when all of its dimensions are unique, it will then iterate through them, work out the dimension number and the amount that that dimension needs to be incremented by. It'll work out if it needs to be positive or negative. It'll work out the dimension, it'll increment the dimension, and it'll send the fucking value through. As currently steps is mutable, as is bird immutable. If I equals steps dot len minus 1. Okay. So you just need to be like let len equals self dot step dot len. Something like that. I could have grabbed the other one anyway. Minus 1. The idea being that, yeah, if we're going through everything and we reset the last one, resetting the last one implies that we're done. If the last digit rolls over, we're done. Okay, so index out of bounds. Ah, right, we do actually need to make sure that we initialize this as being vec 0 vec no, what? No, dimensions. Size. So last here is vec 0 dimensions. Now, question, is it going to break passing in lots of zeros? Maybe, maybe not. Because in theory, like having 2 zeros means that the first time through, it's going to try and do it with a dimension of 0. So maybe not a good idea. So apparently that just does nothing. Oh, that's greatly depressing. And, so why are you just like not working? Are you just never getting to here? Can we climb? Move. Moves. On that. So it's not really doing anything, to be honest.
So we're just never getting to there, which is fun. Are we getting to here? Oh, moves isn't even in existence. Okay, so we do that and we say self.last. Now, my suspicion is that I can't use zeros because having zeros is just going to break everything, maybe? I don't know. Theoretically, should we getting to here? This should all work fine. My suspicion is that it's just not setting things right. Okay, so you say -5, -4, -3, -2, -1. Right. And then you should never have all zeros. So if let some, okay, remember like let next equals step dot next. If let some 0 equals next. Next equals step dot next. What do you mean? Why would it not need to be mutable? Oh no, it's comparison. That's why it doesn't need to be mutable. Okay. Value of next is never read. But that's because we put it here. I'm going to say next. Like so. Hey, if it's a 0, just skip it. Alright, anyway, we went to 5. Okay, then we say 5, 5. And 5, 5 should just be skipped because 5, 5 is 5, 5. Oh, we need to make sure that if so I guess technically 0 is a valid. Wait a second, why are you 5 long? No, you're not supposed to be that long. You're supposed to be steps long. I wonder if that's actually going to fix my problem. That I think what's happening is that they're just always 0. Like there's always 2 zeros. Anyway, so we're skipping that over because in theory, you shouldn't be allowed to not move. So I'm going to say that you can move up to 5. And then obviously you can't move 0, 0. And then you 1, 2, 3, 4, 5. And then you 0. So then you're 5. And then 4, 5. 4, 3, 2, 2, 2. And then 5, 5, 2, 2, 2, 2, 2, 2, 2, 2. Now, the question then becomes, there's multiple all zeros, but now we're skipping zeros, so that shouldn't actually become a thing again. So I do wonder if it's going to work now because, okay, well it crashed. Attempted to subtract with overflow. So why are you 0? Because you started at 0, which means that you actually want to be maybe negative dimension? Which means we would actually want you to be, I mean, technically starting you at I don't know. I could start you at dimension, or end you at dimension, and then start you at dimension, which means it's going to do like a weird flippy flop. But again, that's the order of iteration, which doesn't matter to the actual end user. And so my thinking there is like if it checks every position, so they're all the 1 steps, but it's not showing up any 2 steps. Why is it not finding any 2 steps? Like it's definitely checking 2 steps. So what's the actual outcome of the move then? Well, I mean, technically you can just stay there. And then we just need to put another one here in the print line. And then you would become move question mark like that. So my question is I'm obviously not oh, that's the wrong spot. Let's go here because we have to actually add the dimensions before we lay it. So it's probably not going to work this time. Yeah, they're all zeros. So my suspicion is that you're only moving, say, one. Like the right. So it's because it starts at 0. Yeah. So it would be like by as this plus 1. Right. Because we need to move by at least 1. Okay. Is that general horse movement? 1, 2, 1. Okay. So at the moment, it obviously can still claim its own pieces, but that's regular horse motion, isn't it? 1, 2, 1, 2, 1, 2, 1, 1, 1, and 2, and then 1, 2, 1. Yep. So strangely that. Is that a PC you can get onto? No, that's interesting. So, interesting thing about horses. You can always jump to the same color square, which is a different color square to the one that they're on, I guess. Which goes closer and closer. That implies that if I go like one layer up, and one more, he's landing on the horse itself. So that's a 2 jump horse, right? I don't know which horse I've clicked, that one. So interesting. So that's the horse if it moves 2 steps. And I assume that's correct, because if we go up 1 across 2, or we can go up 2 and across 1. Right. So that horse is definitely moving correctly. See, 3-3, and it's like, oh, you can't move 3-3. I mean, technically good because it's back where it was, but that's not a valid move. Okay. And okay, so we can stop printing that out, and then we can go, hey, so what happens if I said, go back to our moves, yeah, pieces. So, Mr. Knight, what if I said that you actually had 3 steps? Like, my assumption is that you can move significantly further, but also, like, you should be more limited in that, like, when we click on a horse down here, like, you literally can't get anywhere on your own board, but you can get, like, to really wonky positions on other boards. Okay. So if I said we go back to our knight iterator, we're going to say dimensions, which is a U size. Right, so that's the number of dimensions that we have available, and then we're going to also by naming convention, it's an iterator if it returns iters. It's just my own naming convention. So if it returns iterators, then it's an iter. If it returns iterators, it's an iterator. If it returns actual values, it's an iter. Anyway, impl iterator for knight iterator. So your item, type item will be L move iterators. Which I'm going to say you just use super. Nope, not self. Super. Okay. I think once I've got all the pieces implemented, I'm going to call that the end of the stream. Anyway, so fn next is going to be to do. Right. So you return L-shaped move iterators.
And then, so the L-shaped move iterators takes in dimensions, and then so dimensions and next, which is going to be a U size, like so. And then we're going to go impl iterator. No, we impl canite move iterator, fn new, and then this returns something like that, and then we go canite move iterator, and then we need to take in dimensions. So next, I guess, we start at 2, don't we? Because theoretically, a knight in one-dimensional space can't move because it shouldn't exist. Because the only things that exist in 1D chess is a pawn and a king. I like the idea that, like, theoretically 1D chess could be solved. Like it would be a deterministic winner or always a draw because there's only so many moves you can make. You map them out like you can with tic-tac-toe. So first up, we need U public. We need to also make a U public. So U would return a knight iterator. Okay, so you would then say if next is greater than self dot dimensions, I guess it's self dot iterator. If self dot next is greater than return none. Otherwise, we're going to say let out equal L move iterator new self dot dimensions, and the step is self dot next, and then self dot. I mean, technically, we can just do this, and then we can say next self dot next plus equals 1, and then self dot next, and then we just return sum, okay, and that's how that witchcraft works. So technically we need to also still check to see if the piece is landing on its own piece, but the fun thing is that the knight doesn't actually need to check to see if he's landing. So we want to go canite. We probably want to go up to here and say, hey, please pub use knight move iterator. Wait, we want to go piece, and we're going to say, hey, so knight move iterator new, and then dimensions. So that's going to give us an L move iterator, and then for next moves in next, for next in moves moves dot push next. Keep in mind. So this is just going to no one. Oh, because we called it moves. We'll call that L in step. Okay, and then step. Okay, so we're just going to include all of the moves because that should, in theory, give us like the maximum amount that a knight can move. It should just display everything. Whereas as soon as we start implementing like don't land on other pieces, it's like, well, now we don't actually see what the knight can. Oh god, the red main has overflowed its stack. Now, is that because I'm an idiot? Possibly. Or did it just produce way too much? So first off, let's go check and go, hey, if I just said, I'll roll with this for now, go for next in step, in the L move iterator, new dimensions. So we want to say that the dimensions is dimensions and the step is dimensions. We want to go moves dot push next. Now, my suspicion is that in 5 dimensions that is just too much, and that we may in fact need to just like not recursively loop. Yeah. Okay. So I'm guessing just 5 dimensions is too much recursive looping in here. So we need to, you know, make this not do hell. So instead of calling next, we need to so I guess it just needs to return, doesn't it? So we need to be like fn, I guess I'll move iterator would know. So we need to be like fn update maybe I should call it next. What did I call it? Oh, that's the wrong iterator. This one. It's called last. We can call you next. So we need to say update next. Right. So the way the update next is going to be, it's going to mute itself, and it's just going to let step. Just do this. This, okay. So update next, which means we can just go to here and we can go all this, and we can just say self dot update next. Right. So we're going to do it like that, and then we're going to go down here. We're going to go fn check valid. Right, which is just again it's going to take in the self, and then it's going to return a boolean. And then we go here, we go here, we go, okay. So run through that, and then we go, hey, return false, return otherwise true. So if you get to here, you're valid. So then we're gonna go to here, and go, hey, check if self dot check valid, and break. Right, and then we just say loop. I'm gonna say for underscore in 0 dot dot a million. The only reason I'm doing a for loop is because I just have this if done I get this nagging feeling that if I don't do that, I'm just going to end up stuck in a loop or something. So it's like, yeah, just give it a million shots, and if you still haven't made it, just fucking call it good. You see, apparently, even more confusingly, apparently this knight can literally never make it in. He really can't get anywhere near his own. There are places that he can get on the board. They're just not really anywhere near him. That's really kind of fun. Now, I am curious why he can't actually reach... That feels like there might be a bug in my code, because why can't he... Why does he have, like, a torus of positions over there that he can reach, but, like, over here he's, like, can't get to it? Something tells me that I'm not iterating things correctly. That I'm like, missing a whole set of dimensions or something. I reckon what's happening is because we go from negative dimension to plus dimension, we start to... So I think we need to go plus dimension. Plus. Right, and then you start at negative dimension. That's why we're skipping that one. But then you start at dimension. We all kind of start at dimension, but that's fine. They just can't start at 0. So, I mean, in theory, we could just start at 1. That feels like it might be the smarter option. Yeah, it means we will check a couple of spots twice, I think, but that shouldn't matter. Hey, any chance that you actually, like, feel like you make a big sphere this time instead of... Yeah, that seems much better. Now you actually feel like you're building a sphere around. Now, I'm still not entirely sure why you can't reach the top. One would think with an ability to move... Presumably, I did pass in dimension, yeah? Oh, it's because it's a 5-dimensional chessboard, and the chessboard's 8, so you can move up to 5 squares, but up to 5 squares doesn't mean you can get all the way across the board. Anyway, it's kind of funny because you can kind of make it anyway. Now, interestingly, you can somehow jump, like, that's because that's like a negative value. I'm curious if you can land on a queen, like, from your starting location. This is what I was saying. Knights are overpowered as fuck in this because they can move literally in just so many dimensions that they can like jump in like a spiral and land on your queen. Like actually we are the black knight, aren't we? So technically he's not landing on the white queen, but I'm sure there's somewhere. Oh no, because he can only jump 8 spaces. It's 5 spaces. It's physically impossible for him to actually make it to the other side to take any pieces. Interesting. Now in 7-dimensional, he should, but it's a fucking different story. Well, I mean, in theory, because I can literally just tell it to make more steps. I can find out if the night dimension. Well, the answer is no, because it's impossible to have 7 unique dimensions if you're doing 7 steps. Anyway, let's just revert back to the actual correct working code and see how insane the knight's movement is. Because, like, the idea is like, the closer you are to a knight, the less the knight is threatening, because the knight literally just can't get to you. Right. This is also not quite correct, because I think it's actually coming from here. Like, see how they're not offset, so they're... But, like, the knight can book it. Now, what's fun about the knight is that he can't really book it that far, in that as soon as you get kind of any mildly away from him, it's like, well, now you're in fuck knows where's territory. All right, so first off, let's add the offset, because the offset will automatically remove all pieces that are outside of the boards. So I'll move step up with offset position. Right, so we're still going to let him jump on anything, even his own team. It's just, I want us, like, got to get a feel for how far he can actually move. Difference is this time we're kind of eliminating anything that, like, all the pieces out here. It's like he can't jump there, and there's a whole bunch of pieces like over here. It's like where he was actually jumping backwards. So he can get to his own queen, and like weirdly like over here. And you can get all the way over here and like some weird, like, over here and over there. I mean, he can fucking move. It's interesting. Okay. So we've just, I think, just the queen. It's like also because of how his dimensional jumping works, the further away he gets, like the more dimensions he needs to move through, the further he has to physically move. So like as we go up here, because obviously we're getting more and more dimensions away, like as we want to move at least 6 dimensions, at least 5 spaces, we need to be at least 5 dimensions away, which means he ends up all the way fucking over here. Because it's really far away, like it's impossible for him to get to here because he can't step up 5 and then step up 1, 2. Like, it puts him really far away. So it's like sort of like a sphere that grows out in density and like with equal density, and it just sort of spreads out. It's weird. The other option is to pick one that's like more in the center of the dimensions, because like they can theoretically they're more valuable because he can move left and right. Jeez. He can get just about anywhere, but he also, again, cannot threaten. Wait, why can you move so close to the other side? Why? Okay. Apparently that's 5 spaces. Weird. So, that does kind of nix my idea of allowing for 7-dimensional chess, because I'm pretty sure the knights would just be able to kill things like the queen. Because the fact that like the only thing stopping it from being able to take out pieces is the fact that it literally like cannot move more than 5 spaces, and so it's impossible for it to in any dimension reach any white piece, because there are a hell of a lot of spaces that it can go. And obviously as soon as we remove the ability for it to jump on its own pieces, that it's going to radically reduce them, but not really. Like it's only going to take about maybe 10% of them away. Anyway, we got to do that. So that's really easy to do, because all you do is you go, don't print next, please. So it's, you can't jump to your own position, which interestingly I don't think is actually a problem with the knight, because from what I remember when I was just programming it, because we skip 1, it's like it's not possible for it to actually land on itself. So when we do this and we go, hey, if other team equals team moves state, yeah, don't break though. This statement can be collapsed. There we go. So we don't need to break, and the reason we don't need to break is I don't know why it doesn't seem to think that this one can be collapsed. Oh, it's because if you can take the piece, you add the move. But even if you can't take the piece, you can't move. Whereas because the knight can jump, it's like you can collapse it, because it's like you're not actually stopping the move. I do think we want to continue though, because we obviously don't want to add the move twice. I mean, actually, technically, it's the other way. We want to say, hey, if the teams are equal, because the other ones, it's like we add the move if it's not equal. This one, it's we add them. We ignore the move. If the teams are the same, so you can jump on any other piece, but it doesn't block your path. Whereas the other ones, it's like, well, oh, you can jump to where the king should be. I do think it would be kind of funny if we end dimension to the king and said if literally any king gets taken. Yeah, I think the thing with that is you need to remove the ability for the game to tell you there's a check, because then it's about like whether the other player knows there's a check. Because if it, well, maybe it could tell you that there's a check, but if it told you there's a check, then your opponent would know by the fact that you've done something, like, you know, like you took a time or whatever, that there's something happening. But it is really funny because it's like you could the entire game have a king that's like he could have been lost the game ages ago, but they just didn't know because there's just so many pieces. So I'm thinking it does make the king spawning much more boring. Anyway, let's fix that. So, well, not fixed. Let's make that the case, that there's a and then we'll add the queen, and then that's kind of it for the development of the game. Maybe I'll do some modeling. All right. If
is 1 is 4. Okay. So it's kind of boring. Okay, so what was this? This was added knight move. Okay, so now we can fuck around with the knight. So the queen is going to be really overpowered, is what I'm concluding here, but also like hopefully really easy to implement. So you know, knight. The other idea is that we can also just have chess pieces that are different things. Like what I was saying is you could have rooks with different numbers of points on their crown that indicate the number of dimensions that they must move in at the same time. So it's like you could have your rook that spawns next to your king as a 2-dimensional rook, and it's like he can move in any 2 dimensions equally. And then you have a 3-dimensional rook that can move in any 3 dimensions, and it means that like you could have like a whole bunch of different pieces that aren't different pieces except like the amount that they can move kind of way. It's in a way, and it becomes like an interesting concept. So the rook is for each axis. So basically the queen just gets to be like, hey, so slash rook, like, and then bishop. Let me say paste this. I'm gonna go. This is why I did the queen last, is because it's kind of boring. It's just the rook and the bishop. I mean, like dash bishop. Like rook like and bishop like, and then that should just be the queen's moves, because you just trial the moves, and then we go, hey, when we click on the queen, I mean, admittedly she should be pretty trapped because, like in a normal game of chess, she's hemmed in by the pawns on all sides. So when we click her, she literally can't move anywhere because she's completely hemmed in. That's what kind of makes the knights overpowered, is because they're not hemmed in by. Anyway, if we just like get this pawn out of the way, the reason I take a black one and then I'm gonna get it capped is because it means that the black pawn doesn't actually stop anything. So we can like pop her out here and be like, hey, where can you move? So you could like, for example, zippity that way, zippity that way, zippity that way. Interestingly, because she's forced to move in all dimensions, she's actually not that powerful. Right. We could make her more powerful. This is what I was talking about, like, again, if you have each piece, like, have variance on the number of dimensions they can move through, you could make the queen that spawns in the center of the board next to the king really powerful in that she can move in any combination of dimensions, as in, like, she could move in this diagonal where she can end up, wherever she ends up. I guess technically this would be the right spot, but like this is because she has to step 2, and then the next one's here. Like see how quickly like it thins out into, she doesn't really have any more places to go. Whereas, if you let the more powerful queen, like the super queen that's from the center, be able to move in 2 dimensions, and 3 dimensions, and 4 dimensions separately, then suddenly she doesn't go from having like there's 4 places she can land to the 2 places she can land to I don't 1 place she can like, and eventually and now she's like out, they're all outside the board so that she can't land anywhere. That or I'm just missing them. But it would make her so much more powerful because she would just have like a solid bead onto every single board at all times, but there's only one of them, whereas like these queens are like kind of shitty because like sure they're really powerful in the rook dimension because like you can fucking go anywhere that way, like, but like trying to move diagonally with this queen, they very quickly run out of places to go. So interesting. A little bit of balance there. Okay. So just quickly commit that and be like added move. Fine and hell. Alright, so to push that up so that if anyone wants to play with those changes, okay. We have our queen, we have our rook, and now I do feel like I want to like work on maybe some patterns. I'm trying to think, like, would there be a way of doing multiple dimensional pawns? Not really.
because like kind of the thing that makes pawns really funny is that the pawn's going to move in the first dimension. Like I said, they can move forward. That's it. They can jump into any direction. They're going to move forward. Another thought would be like maybe you could make the pawns able to jump in any number of dimensions, because at the moment they can only jump they can only jump in 2 dimensions at a time. So they can, which I personally think might make them quite balanced in that like the pawns can only kind of like somewhat move. Like you can actually end up with pawns really close to each other that can't touch each other because they're on 2-dimensional now. But maybe it would be smarter to be like, hey, pawns can actually like, there'd be a way to buff pawns is to let them jump in any number of dimensions, because at the moment they're only jumping orthogonal dimensions. Anyway, so I also think that it's a bit weird that the pawns have to be separated between black and white because they're not universal in their movement. Like they can't move backwards, so they actually do need to be distinguished. Maybe we should do a poll. But whether people want me to add how do I even do a poll? Engage with the audience. Start a poll. What to do now? Question mark. Make some models in Blender. Add turns. Try add multiplayer. Okay, so we'll do that. All right. We'll see. Okay, according to YouTube, right now I've got 3 people watching. I don't know how true that is because there was a whole ad blocker thing that happened that was like people weren't getting as many views, and I also noticed that when I was streaming during that time, I just like getting no viewers, which makes me think that like ad blocker is also blocking like the stream view count at all, like completely, or like to a level of like unless you've got premium kind of thing. Anyway, it doesn't really bother me, but it's just one of those weird things where, like, I've had people talking in chat when there was nobody in the stream, so anyway, so I think I might, just for my own sanity, boot up Blender while I wait for the poll to come in. But basically, if they get to it, whichever gets a vote first, I guess is what I'll swap to. Well, Steam's booting up. Put that over there. Can I not? I do have Blender. Okay, right, that's why. Because Steam required. It's like I went to open Blender and then Steam opened. If you open in that main, you gotta stop Steam. Every goddamn time. Why does it keep recentering itself on the wrong fucking window? Okay, now Blender's starting. Thank you. Alright, so go like this, go like this, and go like shum, 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 and then we want to go. I want to make a pawn. Now, where you need to go something like let's like Shift A mesh cube. This is a cube, and this cube is 1 by 1 if I remember correctly. Yes. So this is going to be my reference cube in terms of, can we grab you, move you up 0.5. Wait a second. Okay, so you're not, okay, so just scale you by 0.52. There you go. Yeah, now you're a 1 by 1 cube. Before you must have been a 2 by 2 cube. Okay. There's something I gotta do, so Shift A, no, Shift something. There's a apply. Okay. Blender apply scale. What is it's Control A. Okay, so maybe we get out of this mode and go Control A and go all translations. Okay. Lovely. Like this, go here. Okay, so it's gonna be my reference cube for, that's how big one of the cells in the game is. So we're gonna go something like Shift A mesh circle. We're gonna hit circle, and we go, hey, you need 0.5 0.5 on the radius. No, 0.4 because it's each one was like 0.8. And then we're gonna go like maybe 7 because I like, well, I like hexagons, so let's go with 6. Thank you. But the other option is to go with 12. Right, then we're obviously gonna just go, hey, can we extrude this up? Grab, go like 0.2, 0.1, and then again extrude and go 0.1 in the Z direction, and then scale it by 0.75, and then extrude in 0.2, yeah, maybe 1.5, and then scale that down to 0. I'll say 3. Now it feels like it's really tall. And then we extrude you up 0.4, no, 0.35, and then we extrude you and we scale you out 1.25, 1.5 maybe. Then we want to go maybe grab you and go 0.05, and then 0.02, no, 0.15, and then extrude 0.0, that's 1. To be honest, I don't remember what it was. So to go U to U, what is the difference? In Z 0.25 apparently. Good. Control, there we go. Okay. So let's delete that vertices. Nope. That one extrude. So 0.25. No, must be 0.25. No. What the fuck was it? 7. Oh, it's 0.5. Nope. Z 0.05. And then scale that in 0.6. Maybe. I don't know what the actual value was. Oh, okay. I've obviously at some point snapped something to some dimension. 0.6. Alright, and then... Please. Okay. So he feels a little bit big. So that's the smaller one. So just gonna alt click that. I'm gonna scale you up until you're about the same size as that. Yep. So first off, this feels way too tall. So we're gonna grab this and bring it right down to like here. And then I feel like, I mean, it is 8.8. So I do feel like I need to grab all of that and go grab up and bring it to, say, there. And then, okay, that's our pawn. Okay. I do feel like this needs to be a little bit steeper. And probably same with this. It's just a little bit more sort of squished like that. But now the pawn looks like a really long neck. We'll probably grab all of that. Something like that, maybe. So he's going to be too tall, so he needs to be a little bit smaller because the other pieces are going to be that tall. So he's a pawn, so maybe about there. 2 units from the top. Oh, apparently my code decided it needs to be validated again. I don't know what the fuck I've done to fuck that up. Yeah, restart it. Don't mind the terribly written code. Let me just fuck that. Yeah, I don't know. It just works when you restart the code. Alright, so there's our pawn. So rename. Rename. Okay, then we're gonna hide you. We're gonna go, hey, it's time for a. Oh, before we duplicate the copy, paste. We should duplicate the pawn for no other reason than
Kind of want to. I'm gonna open up my other window. What the other pieces look like. Well, according to them, they're a bit lumpier. Anyway, so my thought here is we're just gonna like delete all the vertices here, and then we go, hey, let's make a rook next. So we go, the rook's gonna go up to like maybe here. So it goes 0.6, and then we go extrude the rook. Z direction 0.1, and then scale it out 1.1, 1.25. We want to go grab and move that down a little bit more, like so 0.1 negative. So 0.05. Then we go up 0.15. We should probably check on the stream and see if anyone's voted in the poll. Oh, okay. So I do feel like we need to maybe shorten the rook. So first up, I need to grab that. We need to go grab you, move you down to there. Then we grab you and we go move you down to there. And then from there we can add some like little rookety things. So first just to maybe extrude up a little higher. Subdivide. Like so, and then okay. So we're gonna go all those, subdivide. Dissolve. Okay. Now the question is, can I select here? Nope. Oh god, stop selecting more. Extrude those, scale them. What the hell direction am I supposed to be scaling these fucking things? So I'm going to scale them maybe 0.8. And then that's not right. So something like boop 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 boop. Extrude ZX. No, scale 0.8.
that should then snap to that. And then I go something like, can I like dot, oh, can I go here, here, face, here, here, no, here, face, here, here, face, here, here, face, here, here, face. Then we're gonna go something like alt face. Oh, you don't have the face. Alt face. Alt face. Alt face. Alt face. Then I'm gonna go something like shift. So shift M, control M. No. By distance. Apparently just M. Okay, apparently 0 vertices were removed. Interesting. Despite those vertices quite clearly. Okay, now there's 12 vertices removed. There we go. Can I... Oh, hide that. Looks lovely. Probably want to do that too. Probably need to do that on the pawn as well. Lovely. So that's our rook. I feel like their points are way too tall relative to everything else. So we go back to wireframe and look at it this way. Just grab them down to maybe that height. And a reference to pick on. Oh yeah, lovely. Lovely, lovely, lovely. Okay, so that's our rook. Rook. Okay. Now I need to go back to our reference picture and go, what's next? Can I say fuck it to the horse? And, the horse is gonna be so hard. God damn it. Alright, so then we have to turn you off. We're gonna go copy, paste, and then we go. Alright, so do the horse. I think what we're gonna do is we're gonna do some weird ass scaling. So I'm gonna do something like selectively scale them on the y-axis, scale to 0, and same with you, select these and then scale on the y-axis to 0. So it gives us a little square hole, and then we're just gonna grab you and move you that way, maybe 2, so 0.1 maybe. Same with you, grab you, grab you, grab you, go that way, 0.1. Okay, so that gives us a nice little slot to pull the horse out of. So then we need to go and then we go extrude the horse up, grab the horse, slide it slightly back, like so, extrude the horse up, rotate the horse slightly forward, extrude the horse, no, let's undo that. Grab, no, extrude the horse. Nope. So, we need to go maybe normal, and then extrude the horse along the. Okay. We can just grab it up. And then grab it back a little bit. And then extrude forward, extrude forward, rotate round, grab it, go up. Looking very disturbing looking horse, but you know. The fuck does a horse even look like? That is definitely not the right direction. Grab that one. We need to probably go back to global, please, so I can at least intuitively understand what the fuck I'm doing. I don't know what that's going on about, but yeah. So. Honestly, I don't fucking know what this is supposed to be. At this point, so I want that to come in a little bit more. He needs like a bigger chin. Needs like a fatter head. Okay, so I think like that whole thing needs to kind of come down a little bit. To need to like extrude this out and rotate it. Something like maybe here and like fucking subdivide. 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 What we're learning here is I don't know what a horse looks like. It's a monstrosity, but you know. I think it needs like a mouth. Oh, maybe turn the cube off so I can see it. Right, so what I've done is somehow I've put a face where there wasn't supposed to be a face as a clip through. So delete that face. Well, at least it's no longer clipping. So this here is supposed to be the ears. Face back. Like that. See, all I need is maybe to split that off a little bit, make that a little bit wider. So there's a way to do that, and it's like one of these loop cut. Nope. This one? That's the wrong way, please. Why is it that face that he's pulling off? I mean, it kind of worked. Now we just need to, you know, get the hell off that tool, select this face, delete the face, and then add it back in like so, and then I think it's also going to be the same thing. We're going to need to delete that face and probably that face, and then and then we call that monstrosity a horse. It's a horse that, you know, he's been exposed to the third dimension. He's got problems. You know, you ever seen a fourth dimensional horse? No, I didn't think so. He's got interdimensional cancer. Yeah, he's got interdimensional cancer. Poor bastard. Probably should give it an eyes or something. I don't know. I'm not going to give it eyes because my brain immediately went to, if I'm going to give it eyes, I have to give it like lots of eyes and like spider eyes, and be like, it's weird it's got that dimensional cancer. Which is just a little bit too much for right now. Okay, wireframe, turn back on my reference cube. We go, okay. So what the hell are we making now? Probably a king? Go back to my picture of a chessboard. I think it's funny because instead of like looking up a three-dimensional chessboard, I'm literally, this is my reference for what the pieces should look like. Look at this. I haven't gone and looked up like what three-dimensional chess pieces look like. I'm just looking at the two-dimensional pieces and being like, yeah, that's what they look like in 3 dimensions. So, man, we can make the bishop lengthen. Just make that lengthier. So to make a bishop, I think by looking at this, what we want to do is we want to scale it by maybe 1.1, no, 1.2 maybe. It's just a little bit too small. Now we want to extrude it. I'm going to grab it. We want to go up like 1.15, and then we want to extrude it again by 0.2. And then we want to grab maybe these pieces. We want to extrude those up by 0.1. 5 maybe, and then we want to go here to here to here to here. Okay, do that. I'm going to probably select those and scale it down by 0.8. Okay, so it's looking like a little bit too much, but you know. So then we want to go and extrude this up like another 0.1, and then we want to maybe 0.2, and then we want to scale. Oh, no. Grab 0.2. Okay, but I'm going 0.12. Then we're going to scale it down to 0. Interesting. Again, I don't know what they're supposed to look like. So, I'm gonna make them a little bit shorter. Like that. Then that can be a little bit shorter. Because again, like a lot of it's like a lot of ratios. I don't know, because he needs to be really quite pointy. I feel like I need to scale that whole triangle down so that he keeps that rather pointiness. Alright, what I could also do is we could move this a little bit. Okay. We need to grab this and we need to go in this direction. We need to go like maybe 0.1. Nope. Apparently that's like his whole width. 0.01, 2. Just move it a little bit forward. No, that's horrendous. Alright, so we need to grab these, we need to go down. Something like that. Something like that. We need to like scale the whole thing. Grab it, take it down. Oh, don't do whatever that was. Can we go back to wireframe, please? Then we want to grab this, move it in the Z direction. It's like a candle. Right, so we want to just like tear everything again, and we want to be like, hey, can I like select this and like pop this forward? How do I get it to like tear the whole thing? Okay, now you choose to take. Okay. So we're gonna go undo that. Tear it. No, can I? Oh, that's weird. Well, apparently I can force it along to this line, which. Now he's got a mouth. I don't like it. I made it so much creepier. Yeah, he's got a mouth now, and we're just gonna go back to the regular tool. We're just gonna fill his mouth in. Well, no, not like that. We're just gonna actually give him a mouth. mean, it's kind of what I was going for, but like not really. Now, what I feel like I need to do is somehow like slide. I need to like slide these along. And now I'm gonna like merge. Select all of those, and select one of those, and then merge at last. And then we go A and by distance. And then we go. I don't like it. Mouth needs to be less open. Maybe a little bit taller. Okay, anyway, solid, turn off the reference cube. Fuck knows what's wrong with him. He's a little bit special, you know. You know, this is probably too wide. Maybe it's this that's too wide. Maybe we need to scale. So if I looked at it from this axis and scaled this until it sort of blended in. Okay, so what that means is we need to go like that, and then look at it from this axis and scale it until it blends in. Okay, that actually looks half decent. It's a little bit pointy, but I don't know Blender well enough to be like, I want to just like lop the top off that and make it like a little slanted bit. I feel like I could probably select these and just say like dissolve these, please. That's not what I wanted, but okay. Maybe if I did it one at a time. The answer is no, don't do that. What if I dissolve the lines instead? There we go. It's still greatly disturbing. It looks like he's trying to help me. Okay, so yeah, your name is Bishop. Bishop. Go back to the reference photo. Now, the harder one is going to be the king and the queen. Because I don't know, I just feel like they're going to be harder. So I'm going to go back to wireframe. We're going to go copy the pawn, paste the pawn. Okay, so go into edit mode and go hey. So vertices, faces. So I think we need to select the whole thing and just go scale it up. Scale it up, boys, until it's the top. Go scale it until about there. So what's that? 1.25? 1.25. There we go. So now you're touching the edges, which just makes you that little bit chunkier of a piece. And then I think we want to get rid of all this bit here. So all of that. Look at this way. All of this. Leave that. Vertices. Alright. So then we're gonna go king, 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 king. Channeling all our king energy here. So got a bit of a meme idea for the king. I'm gonna extrude the king up like so. So maybe like 0.25. And then scale it in a little bit and then grab it and go up. 0.1. I have no idea how much I scaled it, but you know. And then we're going to extrude it up 0.12. And then we're going to go maybe scale. So the thing is we need like 1.5, not 1.5. Well, no, 1.5, 1.5, 15, and 6 maybe. And then we're gonna grab that when you're 0.1, not too much, 0.5, extrude. Let me extrude this up 0.1, no, 0.25 in the Z direction, please. Well, no, not XZ. Yeah, it's way too much. 1, 2, and we can scale this in, and then extrude this in the direction 0.1. That's probably way too much. 0.025. Nope. Undo. Okay. Grab. Okay. Extrude. 0.2. No. 0.25. 0.05. And scale that to 0. Now, I feel like there's something else here that I fucked up. Like, why is there a second line? Oh, that's probably just where it's interfacing with the cube. Okay. Okay. So now it's about maybe just tweaking some aspect ratios. So for one, I think he needs a little bit bigger of a face, maybe. 0.2. It's a little bit too much of a face. Okay. Got like a little funny mushroom hat. He has a little cross on his head too. So maybe what we can do is we can go. Can't really do anything about that. So let's just delete those vertices. And this time we just won't shrink his hat in to 0. So we're going to go extrude 0.1. Z. 0.5. Negative. Alright, and then we're going to scale it in to about there. I'm going to say 0.25. Alright, and then we're going to go, here's the king. So apparently the king has a little cross on his head. So 0.05. Well, no, it needs to extrude further than that. So maybe like 0.1. And then I guess from there we would go just like these two faces. These two faces. Extrude those up 0.5. And then these get extruded up 0.1. And then we can, I guess this would also get extruded in Z 0.05. And then from there we can okay, please, love of God, stop selecting fucking other piece. Okay, can I? Okay, base. Okay, so then we just need to be like base select, like that one, that one. We just want to extrude those. Okay, you know what? Fuck it, 0.5. 1, 2. Got a funny little thing on his head. Well, I don't know what it's supposed to be, but. Okay. I feel like I need to give my eyes, but it might be a bit weird. Anyway, so this is the king. King. Okay, so it's our king. So I'm gonna hide the king. Actually, no. I'm gonna copy the king and paste the king, and then we're gonna make the queen. Mostly because I think the queen's probably gonna be pretty easy to like modify the king to be. So first off, I'm gonna make it much taller and thinner. So is 1.5. Right. Then we're probably gonna make this piece even taller and thinner again. Power and face like that's what's going on. I'm going to grab this from here, 0. What's it at? Grab that, go down there. So if that's 0.25. How are you below the ground again? How did that happen? Is the king also below the ground, or like what about the pawn? Is the pawn below the ground? So they're not below the ground. How did the fucking king end up under the ground? Must have grabbed something at the wrong time. Alright, king, you can't be tucked under the ground like this. It's probably best to pop this out and just say zero. Thank you. My king. Okay, and then the queen, same thing. Just grab this and set it to zero because for some reason it's got under the ground. Alright, so she's much taller. She loses the weird shit on top. I'm gonna delete all the vertices. So this is what our queen looks like, which admittedly almost better than the fucking rook. Okay, so we need to give her like a really spiky hat. So I'm gonna go like right click, subdivide. I need to be like extrude 0.2, scale 0. Extrude 0.2, scale 0. Extrude 0.2, scale 0. Should we go check the poll? Yeah, well, people voted for what I'm doing. One vote. Okay. Extrude 0.2, scale 0. Extrude 0.2, scale 0. Alright. So that's one set of spikes. So next is I feel like we need to first off go A, M by distance. So that should make them all the same point. Okay, cool. So then we can go like, hey, look at it from this direction. Select all of these and go face. Right. So now, if I'm correct about this, there should have been a ever so slightly smaller hexagon. Yeah, cool. So then we want to go however many subdivides. So subdivide means you're lined up with you, and subdivide means that you're like lined up with you. So we could take that 3 there, and that 3 there, and then that 3 there. Okay, that's fine. So now what we're going to do is we're going to reach the vertex point. We're going to go you, like this. Right? You. I feel like it needs to be smaller. It probably does, but for now, we're going to go like this, and then we can scale it in ever so slightly. There's definitely a way to make them rounder. Okay, so we have to actually do it as 2 triangles. Oop. Nope, do that. No. So the idea, I think, is we want to collect like all of the intermediate points. like scale them in a certain percentage. So probably only like 0.95, something like that. Then we're gonna go A, and we're gonna go well, I'm gonna select all of this top section, like this. No, I'm gonna go one more lower. I'm gonna triangulate. Interesting. It should be fine. Just feels a little bit strange. Anyway, I'm going to scale this out, maybe? Yeah, scale it out by like 1.2, 1.5. 1.5, yeah, that seems like a really cool little thing. And then we can get rid of the big center hexagon, like so. Delete. Nope, not delete. Face. Okay. So, something about this. So, I think it's like this. Maybe this. I feel like maybe selecting lines might be easier. Face, face, face. Nope. Face. Nope. Too many lines. Face. Face. There we go. Ba-doop. 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 Ba-da. Nope. Okay, and then can I like alt click this and back? Okay, now if we just turn on the cube, that's a pretty mean looking queen. I like it. I do feel like the queen gets to be taller. Because the idea is that the cube is about when I spawn in the move pieces, like you need to be able to see that you can move to a place even when the so like in theory that like the rook can also be taller in that you'll be able to see that you can move there, like in between these little things. We could make the rook a little bit taller too, like that. So like basically like the little bits can poke at the top. You're just terrifying. I really don't like you. You disturb me to no end. Bishop. Okay. So we can probably not export the cube. Now, in theory, we need to rename you. Rename you to Queen. Okay. So, close. Can we get out of edit mode? Okay. So I want to first off file save as. Go here, projects, NDHS, assets. Low poly. Yes. Okay. Well, maybe we should call it set. Right. Anyway. Then we want to go export. What's the format? GLTF. Low poly. GLB? Sure. Don't export animations. Include selected object, visible objects. Because I don't really need to export the cube. Okay. So that should, in theory, have exported all of the GLTF stuff. So I can then import them here. So I do want to like override my asset stuff.
mostly because I think it'd be funny. So we go to assets, and we go wherever the fuck this is, piece assets. So let's go to piece assets and go, hey, any chance that I can replace this with a hash map? Stick collections platform. Collections hash map. So we want to chess piece, handle mesh, like that. Alright, so that should work. And then first off, let's go make sure that we've committed this. So yep, okay. Cool. So the only things that I'm changing are related to this. So we can then say assets dot get and then piece. Right. So then we go to wherever the assets is again. We just need to make sure that when we import piece assets and say fm so you're probably saying that it doesn't have hash, but anyway. So we're gonna say unwrap or default. Unwrap or else, no. Oop, unwrap or default. I think there's a default hash, I'm not sure. Alright, so you're telling me that it's probably that chess piece doesn't have hash. Thank you. Okay, so now it doesn't have a default. Wait, what doesn't have a default? Dot cloned, please. Now it has a default. Okay. So I gotta work out what's happening down here. Is that each of these? Okay. So I don't want to lose all this, but I want to be like, can we make the geometry set? So can we fn geometry set, and I guess it can just take new cell, like load geometry set, and then you're gonna need self and meshes. So first off, we go meshes. Well, first off, the pawn's not the sphere. Who is the sphere? The pawn is the cube. Where's the cube? Alright, okay. These will go up here. When we say self.meshes dot insert chess piece pawn cube. Right. And next was the, who knows? What is the order of these? Rook. Okay. So insert rook, and the rook is cylinder. And then knight was capital. Bishop was cone. Queen was not sphere, but yeah. King was Taurus. Okay, so first off, queen is Taurus because Taurus is definitely the queen shape, and king is sphere because round king. Just hash map default like that. So then next we want to go up here and be like, go to here and say let new out equal then out. Okay, so I'm gonna just like have the load geometry set, but we're not actually gonna use the geometry set. Load poly. Yeah, need self. We need the asset though.
asset server. Now, technically, I think it might actually be smarter to do that with same here is we said you actually take the asset server, and then we can say instead of we say asset server. Because now they both take the same thing and it doesn't actually make a difference in terms of how I actually do things. Meshes king away, and then we say, hey, load the two materials, and then say, hey, let asset server equal load the asset server, and then we say, hey, any chance that out.load low poly set, and then we pass in the asset server. Okay, so then interesting. So that, no, that's not how that works, but okay. So first off, it would be asset server dot load what was it called? Rename, copy it. Oh. Rename, copy. So it would be low poly hash don't think it's mesh 0, but I don't actually remember. So we can just say mesh 0 slash perimeter 0, but I feel like we can get it by name. Like I think because we called it pawn, we could in theory load the pawn and then load the rook and the knight and the bishop by shop. Okay. So do this. For some reason we missed that one. So you would be then probably like, because again, I don't know what order they're going to be in, so the hope would be that we can use their actual fucking names. But then I think it would run into issues. They're probably called scenes or something. And then because they're called scenes, ugh. Yeah, it's going to be weird trying to load GLTF stuff. Or not. Their normals are all fucked up, but that's not hard to fix. I think they're in the right spots too, which, to be honest, makes even less sense because that should have just been arbitrary. Question: are you actually the king? I think you're actually the queen. You know, that's yeah. So the king is the queen, and the queen is the king. But for that to be the only issue here is kind of like kind of baffling, to be honest. But you can't go anywhere because there's like pawns in all the directions. Alright, so first up we'll fix the normals, but we also need to swap where a king is, king and queen, so you're actually 5 and you're 4. That's so bizarre because it's just arbitrary and I just got it right. Anyway, go back to Blender, go hey, control, go into tab on all of you, can go A and then can go Shift N. Then we want to go one of these, that's a C normals, I think. This one, and then we go like face normals, and go hey. Let's go ahead, edit mode. Go yep, you look right. Okay, you look right. You look right. You look right. That's a poor horse. This is why you don't travel through multiple dimensions. The horse is the most overpowered piece, but he took it hard when he traveled through the multiple dimensions. Export export. To be honest, I have no idea if the renaming shit's still working. Okay, we're gonna rerun this and we're gonna go, hey, any chance that yeah, I think my code broke like an hour ago. Why is my renaming code never fucking working? Oh. It works when I prompt it to, but it just doesn't work on a timer. Weird. Alright, so you move to like here and then you're the king, you move the king out and move it up. Blip, blip. King's fun because king can go fucking anywhere. Send the king over here and be like, bloop. King can really just
move. Hmm.
Alright, so there's obviously a need for like turns. So basically, you don't want to just be able to like move the black pieces around. Admittedly, like you can do that in real chess, in that it's stopping you from moving the other person's pieces around. Except yeah, general rules. Okay. So I do feel like I need something also to like point to where a piece can go if it can, because like the rook, for example. No, even the knight has the problem. The bishop, not the rook. The bishop. Like, because the bishop has to move in every dimension, it's actually really hard to work out where they can go. It's also really hard to get them the fuck out of home, because where... So you would need to go up one, forward one, across one? So is it here? Is that your next location, Mr. Bishop? No, fucking... apparently not. So one, so it's 1 dimension, 2 dimension, 3 dimensions. 4 dimensions, 5 dimensions. So it should be here, I think. Maybe. Wait, no. Wrong bishop. This bishop? Yeah, there we go. Yep. Once he's out, it should be pretty easy to like find more places to move him. But like you can see, like it's really hard to work out where the fuck he can go. So like he's gonna need some like lines or something pointing to like where he can go, and maybe just like places that he can move if there wasn't a piece, like so that you can go like, oh, like if I can get this piece out of the way, then he can go here and here and here and here. Mostly because it's just really hard to decipher what the fuck moves it can make. It is kind of funny. So what are we doing? I guess we want to add turns, maybe. Okay, so I guess we may make like a module called game, and the module called game will actually handle the logic of like who's in control, I guess. So game, and then we want to do like use Bevy prelude like that, and we want to go obstruct current player. Okay, and then yeah, him. Pub him. Team. Right. So we have the current player, which is needs to be a resource. Okay. Now I don't want that to interfere with the selection, but I do need to go like where the hell is the move pieces? Because I want you to be able to click on the other people's pieces and like see where they can go, but like you obviously can't move their pieces. So direction. So somewhere one of these pieces there's like a function called like it's gonna be in board. Spawn board, current piece. No, maybe piece. Is there like a move piece? Clean up display possible moves. Make move. Move to can move. Get target can move. With possible, okay, so wait. Move to. Right, so this is what happens. So selected. Okay, so this is the selected piece. So we need to go like the selected piece should also have a team. on it, and then we just need to go like, hey, current. No, just player. Player, which is going to be res active player. Yeah. Because current player. Current player. So, don't click whatever that was. Okay, so qualify current player. Right. Cannot find game. Yeah, it exists. So, right. So then we can say So selected as single. So we can just say like before you even work out if it's a valid target, just be like let selected if selected.2 does not equal player team with turn. Okay, so basically you can't move if it's not your fucking piece.
There's not much you could have done.
I also feel like we want to go like display possible moves. When I display possible moves, when I want to display possible moves, I need to like recolor it if it's not your piece, so like they just show red moves maybe. So possible methods.
When it comes to what they did, my
Display possible moves. So so somewhere I'm like cloning and transforming and mutating and fucking doing all sorts of weird shit. Trigger on add selected move on all moves, possible moves. Yes, query, creatures, teams, guys. So I do feel like this is something. So possible move asset. This needs to be public so I can access it from the other thing. And I need to like this is something I want to put in the player side of things. So what does this happen? So this triggers on add select. Selected. Okay. So when you go game, we go fn change change new color if not your turn. Okay. So it needs to be selected on move selected. Right. So this needs to be pulled in from wherever I've got that. Okay. So selected's obviously something somewhere else. So you need to also be public. Okay. So we got a game. We got hey selected. Can we bring that in now? No, apparently not. Import selected. Create piece selected. Okay. And then we also need the select move assets. I don't know what it's called. Res possible move assets. And we also need player. So current is current player. And my code has decided it needs to be authorized again. What the hell is your problem? I legitimately have no idea what's wrong with this fucking code. Anyway, I need to go back to it and press F5 first. Yep, F5. Yep. Alright, so you're available, yep, can't find, okay. So then we have that, and we go, okay. We also need access to mute materials. Okay, res mute standard materials. So what I'm thinking is if you are black and you select white, sorry, current player team. So we're gonna go to team. We're gonna say
hub team. Okay, right. So they just return the two colors. So the way it's going to work is that when you select a piece that's not your color, the moves will be in the color of the piece that you've selected, and green if it's your piece to move, and red if it's not your turn. So we're going to say this will trigger on a. So we need to like, first off, plugin, init plugin, game plugin. Okay, so we need to go first off. Okay, insert the resource current. This is not, no, this is an observer. Dot add observer change when it's not your turn. Okay. So first things first is we need to go select it. So we need to go. Well, first off, can we just like make you like T? Well, I guess we do use it, but like it's gonna be them selected. Selected. Single. So we just need the entity with selected. So I just need the team, I think. So the way it's going to work is if selected dot team does not equal current dot team, then we need to make you public. Okay, so what's cheeky about this is we could actually update. I don't know if it's the best way to update underlying mesh. You need like a redirectable handle. So the idea would be that if we update that so that when you select a piece, it's like, well, the current position piece, like where you can go, is actually like the piece that you've selected. Like it'll be a bunch of rooks around rather than green circles. Anyway, so not great, but anyway. So we say, hey, I feel like I want to get this material regardless of anything, and then so let some material else return error possible move material. Right, then we go here and we say, hey, so if the teams don't match, then mat dot base color equals team equals selected dot team color. So 0, no, I think we maybe have to deref you, I'm not sure. Right, so I have to double dereference you, that's so fucking stupid. Right, so if the selected color team is not the same as the current team, then display the move in the current color. The issue with this is I can't see how you would ever select a piece that's not yours or the other teams. So because what I'm thinking is when you play chess, like you are white, and that means that you, like if you look at the other pieces, but like at the moment it takes turns back and forth. So if it's going to swap back and forth, it means that when you select a piece that's not yours, it'll show up. But then when it goes to once you've made a move, it's now you are the other team, and then so they move. But in multiplayer that won't be the case. So current player, and we also need a pub struct player, which is going to have a team. So I guess this wouldn't be current player, this would be current move. So we can then also change this to being
a team like that. And this would also be a resource. Right, so I also want you to be like deref. Alright, so like that. Need to double dereference you because you're annoying. What do you mean it can't be dereferenced? What? No, I typed in debug, deref. There we go. Okay, so if the selections in the current move, so it's not your turn. The piece is selected and the current turn is wrong. Don't do that. Okay, so then if... Well, no, it's the current move and the... So we need the player. Player, which is res player. Right, so we need to say if... if player dot team does not equal current, right, that's the current move, then so if the selected piece doesn't equal the player dot team, then that, right, and then we return. Then if the player's team does not equal the current team, then color sRGB linear RGBA 1 0 0. So we go that, otherwise it's green. Okay, I think that's logically correct. So if the current turn isn't yours, but because we got to here, we know that it is actually your piece that you're selected. Select the right piece, but it's not your turn, it'll be red. If you selected the right piece, and it is your turn, it'll be green. And if it's the wrong piece, then it'll be that team's color. Okay, so then we say current move, because it's chess, current move is white. Team white. Right. We also need to insert resource player white. Now, at the moment, we have no logic to stop. No. We have no logic stopping the one player from moving the other player's pieces, which is kind of funny. So it's not player, it's move. Next move. Can't. Okay, fucking next move does 0 maybe. Why can I not dereference you? It's so fucking stupid. Dot as ref. Do I have to dereference you as well, you piece of shit? Okay. So now if I pick a piece that's not my team, which I think I've just assigned team to white. So if I pick a black piece, it should show all their moves in black. Apparently you can't move at all. They didn't like that. Wait, what? Resource does not exist. Current move. I mean, oh, because we haven't actually added that to the game. Yeah, that would make sense. So we go back to main and we go, hey, can you please chuck in... What? No, don't put the editor back in. Just put the game plugin back in, please. Oh, back in. Just put the game editor in. When did I hit F11? Alright. Well, you can't move anyway, so fuck you. So your pieces are black because it's not my turn. It's not. I'm not black and it's white's turn. Well, it's not. I'm not black. So when I click you, they also appear black. So that's fucking stupid. Well, now they're green. So yeah, that's fucking stupid. Anyway, white can win because white's the only one allowed to move. So when I select you, interesting. So it's just not actually working properly. So I think this is where we go. I suspect somehow things are getting double triggered. So no, because it could. Okay, we need to make this like a query. And we just say let okay. No, this is make move. We don't care about make move. Make move can be single. We need to do reference that again. It's the game version. So I think what's happening here is that we can, in some, because of when this triggers, we can end up in a state where let okay selection equals this is a query, and we're going to say get t.target. Right. So what I'm thinking is happening is that it's there's momentarily two pieces being selected, and then it's just not running this because this only runs if there's exactly one piece selected. So when I select you, it's black. When I select you, it's green. When I select you, it's black. When I select you, it's green. It's green. Okay. So next we have to somehow make it so that we are black, but it is white's turn. Okay. So one thing about that is when we go here, when we go to piece and we say, hey, make move. Really, I think make move should probably be in the game section. So just actually do that and go, hey, game, make move. So you need to like import a whole bunch of stuff, which, where's possible move coming from? Okay. Board state can come in. So we need to find possible move and we need to change you around so that that observer is in the right spot. Display possible moves is not a okay thing. All right, so what's a possible move? So we need to track down where possible move is possible. Flip the word move. And go, we use that way too many times. Okay, go back here. And go, hey, possible move. Where the fuck do I use possible move? Okay, you need to be public so I can grab you. Possible move. Then we need to go here and go import possible move. Okay, so then we go back up to the top here and we go, hey, can we add observer make move? So the making of the move will also be what gets whose turn it is. So is it possible for me to implement not as a thing? That'd be kind of cool. So next move, if we get to here, which ironically is your actual crate. Where's the minute you goddamn birds so loud. Next move is got 0. Huh. Okay. So we will still be playing white. We'll still be able to move black pieces, but we'll be able to see if it displays our pieces as in red when they're not valid. So So you're black, and then you're green, and then we move you, and then we go, hey, if I pick you again, you're red, because I'm white, but I can't move there. And then black can move, and then green. So I can jump you, I can move there, and then I can click you, and I can say, hey, you can jump to there, and take that piece, and then, well, now it's just chess. I think the idea is you could just play chess on here. Actually, no, you couldn't, because the, well, the knight works fine. I think the rook works fine as well, if it was, yeah, the other way. The rook seems to work. That's a-okay. You're the only one that doesn't really work. The queen. The queen also has the same issue, that because she doesn't follow the same rules as the, move you out of the way. Move you out. Please, just need you to go out of the way. Right, I need to move something else. You, and then go, hey, and then go, okay, so the king, same thing. So you can move, so what we need is to, I think that's the trick, is we need to modify the rules for the basic rook, that if you were on the correct tile, like the center tile, the true world tile, I guess, which kind of hard, because what the fuck is the true world tile? I guess because the kings actually do face each other. I always thought the kings were opposite, I always thought like one king was here and the other king was there, like the kings weren't in the same file, like they weren't in the E. I thought it was like one was D, one was E. So it was like a symmetrical board rather than a opposite board. And I think like that would be hard in this particular case, because like what one becomes canonical, but like canonically the kings are in the E, so canonically there is one board that all the king, like all the pieces can be like in this canonical board. You are in the true universe where everything follows the rules, and so we need to make sure that like all the default pieces spawn on that board, and all the default pieces can follow those rules. So what we need to do is like modify the bishop, so that like you could literally just play a regular game of chess, but in 5 dimensions, where it's like you sneak off and try and move a piece that's like, yo. Anyway, that's so silly. Anyway, so what was next? So that lets us move those pieces around. Now what I want to do is, so this is possible moves. So what I want to do is also have like legal moves, maybe. So let's rename this to legal moves. Legal. I don't know how to spell legal. Legal. Okay. So legal. Right. So the reason it's got a legal move is because we're going to have all the illegal moves too, but we're going to give them every color so that like you can see like where the pieces can get to if there's nothing in their way. Because I feel like at the moment it's really hard to tell what piece I need to move so that I can move a bishop. Now I need to commit this, so we're going to say added turns. Right. So how do we do that? So I think I'm going to go again, drive component, and we're going to call this a shadow move. Hub struct shadow. Right. So a shadow move is going to be the same thing when we say, one of the things is like literally called all moves, but it doesn't actually show you all moves. So import piece assets, load, no. Nope. Let's spawn pieces. Piece editor, update piece position, no. One of these is like just literally just call the piece like, the fuck is the function? Clean up possible moves. So we're gonna be like, or not okay, or so we're gonna get something like or with shadow move. Right. Right. No, wrong one. You were correct. Your if something had selected removed, it's or with no shadows. Right. So that should then all right, hilarious. So basically if we have nothing selected, which is why it's a removed is empty, we just despawn like all the moves that are on the board. Now I'm going to work out where exactly I spawn. Okay, pieces to all possible moves. So first off, this doesn't actually return all possible moves. So what we're going to return is like a tuple. So this is going we probably turn it into a struct so it's actually usable for other people instead of just me. Struct moves. Right. So then this is going to be shadow moves and legal moves, right? And then you return a vector of moves. Right. So now instead of returning early, so we're going to say something like your moves new. All right. We're going to well, maybe we can just drive default. Drive default. Right. Moves default. Right. So then we're going to go down here and we're going to hey, so dot push underscore legal. Right. So we still need to implement you. Yeah. Implement moves. Push legal and push shadow.
You'll never know what that is.
Okay, so we go here, we go hey, so you need to be like push legal. Right, no, I think you're also push legal. Now, I don't think I want to necessarily like show the pieces that are like how the pawns can only jump diagonally because there's a piece there, for no other reason than because it seems not that helpful. Like what I'm trying to add with this particular with this particular thing is like the ability to go, this piece could move here if I got rid of everything in its way. So push legal, and then when we get to here we're going to say moves dot push shadow. And it's pos apparently. Alright. So the idea being that like I want to know what's causing blocking and stuff like that. So this is going to be a little bit more difficult. So the way this is going to work is so the next instead of through, so we're going to say let shadow equal false, like so. And so this is anywhere we've got push at the moment. So I'm going to push legal, push legal. Right. So instead of breaking, I mean technically. When you get to here, don't break. We're going to say continue, but shadow equals true. Right. And then we're going to say if you get to here, it's if shadow else push legal. right, like that. And then you're going to be the same thing where you just have to reset shadow because obviously like, well, you need to be mutable for one thing. Then we're going to say shadow equals false. And then so you'll push underscore legal and then shadow equals true. True and whoop, continue. Now, interestingly, that's going to run into the small issue of I need to include in here somewhere that because you set shadow to true because you're what blocks it. Ampersand not, because the idea is that like it would stick a legal move in if it got to there. Oh wait, no. It's is it here? No. I guess technically up to that point, because this is checking to see if a piece is blocking it. So I'm saying like, hey, and you're not shadow. So when you're in shadow, don't even check or don't bother checking. So then you'd be the same. Is we would need to go here and say and not shadow. Because once you get to here and you set shadow to true, you're basically saying, oh, you also need to push the move as a shadow move here. So why are you cloning next? Why are you not just pushing next? I don't know. Anyway. So shadow, and say if shadow, push shadow, else push legal move. Don't know why it's cloning it all the time, but anyway. That says the rook and then go to the bishop. And it's the same thing where we need to go shadow was false. Position, push legal. We need to say ampersand, not shadow. You need to be a continue. You need to be else move push shadow. And then if shadow push shadow else push legal, then you go away. Right, so that's again same logic. We're just gonna pack all that in there, and then the knight. To be honest, you push legal and you push shadow because it's just saying like it could move here if it wasn't blocked. So then you do the same thing. Else push shadow, push legal, ampersand, not shadow. Continue. If shadow else. Oh, come on, push legal. Alright. So that should, in theory, mean that each piece now tells you whether it's a legal move or a shadow move that it's giving you. And so all possible moves. So that all equal all possible moves. Right, so passing all that and then pieces. Apparently we have to pull some kind of weird ass transmutation mutation fucking logic, get that to the right type. And then for this we go okay. So for legal or allowed in legal moves. Legal move. And then we say for shadow. Shadow move. And then possible move material. So you would not be we need pub shadow move material like that. So the idea is somewhere constructing this. So we need to make the new possible move material. So it needs to be like red, but be dark red. So like a darker red to indicate like that it's not. And this is shadow. Material. No, any shadow material. Right. So that would give us that, and then that, and that, and then what are you complaining about? Something in here is not set correctly. What is not set correctly? Okay, here, the queen apparently. Oh, we only do the bishop moves on the queen. Okay, god damn it. So yeah, that shadow equal false. That mute shadow equal false. And then we say shadow equals true, or that everything else didn't do that. Else shadow move. Push legal move. Okay. So then again, you arrive. If shadow, and then we get to here and we say, hey, shadow was false. I don't know what the fuck happened there. Push shadow, push legal. Continue. Shadow equals true. I mean, technically, we could probably get rid of that and like just set shadow to true and then not continue. Like we could. We also need to say end, not shadow. Like, I'm pretty sure in theory we could just do that. Get rid of this bit. And then we just only put, oh, no, that's the wrong one. Nope. I don't know why I'm modifying halfway through, but anyway. So, do that. Okay, so then are you doing the same thing? No. So we didn't make you mutable, and then we don't set shadow equals true. So again, I feel like once we set shadow equals true, we can just get rid of this and be like, hey, just fall through and do the right one, because we know that if it falls through, the shadow is going to be false. Wait, no, because then we can push illegal and illegal. So no, don't do that. Push shadow and continue. Because there's nothing making it not fall through. So like if it gets pushed legal, it'll still fall through and then get pushed to shadow as well. Which, I mean, wouldn't really be that big of an issue because it would mean it's spawning a little bit extra stuff on top. So that's the king. Shadow, and we also need you to continue. Continue, please. Okay, thank you. So king doesn't care. Shadow, shadow equals true. So that's bishop. And then you're the same. So if the teams are the same, right. That's knight. Oh yeah, again, knight doesn't care. We only push shadow if it's landing on its own piece. Just pop the rooks open. Go, hey rooks. Shadow goes true. Push, push, push. Shadow goes true. Push, push. And then obviously the pawns we don't care about. So, now apparently there's still at least one red line that I've missed. Because somehow I brought in E. Weird. Alright, so when I click you, oh, something like the queen. It should, in theory, be showing me all. Wait, it is showing me all the moves. I'm just apparently doing it wrong. All possible moves. Apparently, it made it public. Yeah. So when we spawn in, display possible moves. Did I not? Yeah, okay, so I didn't change the material. This is shadow move material. So in theory, the shadow move material should be something other than the shadow moves. Like it should make it obvious that these moves aren't really moves you can make. So they're all shadow moves at the moment. But it's saying like these are the spots that the queen could actually reach. Interesting. Okay, so this seems useful because when you go like, hey, where can this rook get to? A bishop, I mean, not a rook. So it's like he can get to there, and then he can get to here. It's like you can see. You can see more clearly like what's stopping him from getting to where, and where he could possibly move to if you could clear the path. So it seems more useful than like first up we click you should also click your queen. So it's all red, but then we grab a U and move you. Oh, that's not a good sign. So when I select you and I select you, for some reason selecting that doesn't despawn all the possible moves. Clean up possible moves. So that's only called when it does it. Okay, so wait, it's the old or shadow moves. Okay. That should now clean up the shadow moves. Things like that. No, when you just select like you, and then when I select you, okay, it goes away, and then we can do this, and then I can do this and say I can move like here, and then when I click you, now you can actually like go, hey, like you can move to here, but you could also move to here. So it also shows how like god awful weak the queen actually is, because like she can't move to these spaces. Yeah, so she's actually significantly weaker than a regular queen would be. Which is interesting. Interesting. I actually think that's probably incorrect then, because theoretically the queen in chess, because like again, to be the powerful piece that she is, doesn't have bishop movement. She has the ability to choose to move any amount in any number of dimensions. So if we actually gave her any amount in any number of dimensions, she suddenly gets all her movement back on the normal board. But again, I feel like the bishop really should work like the bishop, at least on the center board. So the bishop also just needs to be able to move in 2 or more dimensions. So because otherwise, like, he really is very quite limited about where he can move. So maybe we increase the number of positions that the bishop can move to. So let's commit what we've changed. This is what did we even do? Okay, display all moves even when blocked to allow planning. Okay, so what's next? What's next? Right, we were going to fix the bishop. So at the moment, which ironically we go to iterators and we go, hey bishop. So at the moment, the bishop move iterator. So L move. So this is a so this is like an end diagonal mover, and so we want like a pub struct diagonal I can't spell now. So we want a diagonal iterator. And the diagonal iterator, see, I don't feel like I want to specify a distance on it. Like the distance is maybe useful for some things, but I feel like you want to like const dimension. Which is a U size. Like so. And then we say how did you even move? I'm trying to remember. So you're a dimension iterator, and so you have well, you would just be like my brain is not working. So you would just have like a step, which is just going to be a U8 and a dimension, which is going to be an array of I8s by dimensions. I guess direction makes more sense. I don't know. Alright, so the way you're going to work is you're going to be like a dimensional iterator. I'm going to paste you down here so you're at the bottom. So diagonal iterator. So new, and then dimensions, and then you have like, yeah, 1. Now, you did some fancy bullshittery, didn't you? So the way you currently work is that you like ink or deck a specific. So I guess maybe that's how we should do it. It's just be like bool dimensions, and then oh no, because it's it would be an I8 because we need to go up and down. You don't need to store the current because it's literally like so. So you do this, and then you'd say, "Hey, I don't know, dimensions." I haven't stored a key, and this key is just yeah, I don't know how you fucking sure. And yeah, just the key. So we would then need to impl const dimensions. Well, see, you would still need to know the different dimensions, which is ironic because so technically let's change this to axes, because what's ending up happening here is that calling two things dimensions, but like one's referring to the number of dimensions that we have and one's referring to the number of dimensions we have, the freedoms, dimensions of freedom. So if step is greater than 7, I think we want to say step is an I. Maybe, no. So step can be that. I mean, technically, because we can go both directions. So it's like you do 7 steps, and then we say, hey, position, you're equal to 0 times not dimensions. Not dimensions, self dot dimensions, because that's where that comes from. Self dot dimensions, right? So then we say for I in dir. No. That's wrong. Direction. So it's more like for dim in self dot directions dot direction dot zero, right? Something like that. And then we say, hey, so this is the dim, and then we say let heat equal dim dot pot neg. What the fuck was the thing? There's like a weird word. The L move, does the L move have it? It's a fancy fucking unchecked. Well, it's probably inside here then. Apparently the answer is no. What the fuck was it? Signum? There we go. Signum. So we get our signum, and then we say yep, and then the IDX is this, and then we add member on IDX, and then it's that times step. But the step is 0. We have to always step at least 1. So I think like what you do is you go, hey, if step's greater than 7, and then you go, hey, increment my step. You then go, hey, for each dimension, unsigned absolute. Weird. So we say get our direction, then subtract 1 from that, then position, add dimension. So we do need to say assert debug assert like self valid key. I don't care about the dimension, just valid key. I mean, technically, I guess we should take that in and be like valid key. So the way this is going to work is neat scene
dimension. So for dim in inner, let x unsigned absolute -1. If xt is greater than dimensions or seen false, seen ix equals true. Okay, I mean that's a clever way of doing it. Right, so we have this, which should iterate through each dimension, each axis. So I think this works. So this gives us dimensions. Const iter dimensions. Iter. I think that works. So what we would then need to do is we need to first off check that this is actually returning what I think it's returning, which is a real pain in the ass to do. Because what we need to do is we need to go to pieces, we need to go, hey, where's bishop? Bishop. So we need to go, hey, bishop, I need to turn off your old code. And then we need to go for next in move iterators. I don't think I made it public. Right. Primitive. Well, I probably just didn't export actually. Yeah. Okay. So we need to go up to here and we need to go, hey, pub use primitive diagonal iterator. So we go to here, we go pieces, and we go, hey, diagonal iterator that has a size of 2 new. So it has a dimensions of dimensions and a key, and the key needs to match to 2, which is that you are going to say iterate dimension 1, comma 2. Right. And then I guess we just run the same logic as before. Except, you know, uncommented out. So next is, okay, so it's dot with offset position. And then, so I guess technically when shadow comes out here, and we get rid of that layer of that loop there. Okay, so this should, in theory, iterate through dimension 1 and 2 positively. Board get next not shadow. So what I do with that should then give me 2-dimensional axes through 1 and 2, which should mean that more or less regular rook movement. Apparently the answer is no. What if I moved over to like a rook over here? The answer is apparently still no. So can we print line? Where the fuck are you trying to move? Are you trying to move at all? There's a good chance that like it's just getting the wrong number entirely. So it doesn't appear that you're actually even making it that far, so that's fun. So direction, so that means we gotta go one layer deeper, maybe the iterator. Go, hey, can you like fucking print out what you're gonna do? So you're gonna print to position, right? Self.dimension. So you're printing out you want to go from step. Okay. Wait. Self.direction 1, 2. Yep. Which means you go from position 1, 1 to position 2, 2 to position 3, 3 to position 4, 4 to position 5, 5 to position 6, 6 to 7, 7 to 8, 8. Now I don't know how you got to the 8s, but why is that not considered valid? So we have to go back to our like offset iterator. I'm going to go, hey, like what? you to please print. What the hell you seem to think these are? So what do you think that they should be? So so what's happening here is that this is the wrong way to iterate for that specific rook, which means that if we go to a white rook, do they work? Okay, so that white rook and then that white rook. Right, and then that's how rooks should move. Okay, so that's a two-dimensional rook move, and then so what we need to do is make sure that we actually iterate through all of the possible dimensions to check. So that means we go back to our, not a primitive, bishop. So you are now going to return a, okay, dimensional iterator. But you're going to dimension iterate through two dimensions. Why is it still called distance? Not dimension iterator, diagonal, no, go away. This whole thing goes away. I need a diagonal iterator. Diagonal iterator. Right. Dimensions. 2. So the way that you're going to work is move set. So I need to iterate through every dimension and then with every other dimension to give me all possible two-dimensional moves. Okay, so what we would need is, I guess, dimension A. So A, which is going to be a range I size, and B, which is also a range of I size. Okay, so the way it works is if, and then we have, like, maybe we have something like done, just because it's, I can't be bothered thinking of an elegant way of keeping track of if it's done or not. Wrong range, aren't you? Yeah, no, you're not the range I'm talking about. I'm talking about qualify, no, not qualify, import, and it's SQ range. Okay, I think. No, okay, wrong range then. Is it ops range? I think it's ops range. Okay, so we have a range and we go, hey, so if done, return done. Okay, so then out, it would be this in dimensional move. Okay, so no, that's not correct. So what we need to say is let sum b. I guess if let sum b equals self.b.next, right? So if you get some b, else self.b equals we see we have no idea what the a was, is the issue. Goddamn fucking code. So last yeah, underscore a, which is gonna be an I size, like so. Then we just go, hey, okay, so no, so if done, well, if self.done, right, and then we say, right, so if let sum b equals self.b dot next, don't know to do
else we need to say self dot b equals negative so we need to check negative positive of all axes. So we need to go negative self dot last a dot absolute plus 1 to equals self dot len. Right. So that should check all dimensions, I think. I think technically you want to add +2, and then we say, I'm just going to kill this code because it's not worth the annoyance that is it trying to constantly do shit, just for the sake of renaming the stream. So let b equal, right, and then we just say b. Right, so if you get sum, we just say b. Otherwise, we assign b to this, and we return self dot last a. Well, actually, yeah. Oh, maybe. Oh, that seems like it might work. So, all right, we just return last a. Oh no. +1 maybe? I don't know. As I size. Right. I. Not equal. Just. Right. Well, no, it is equal. Wait, but less than or equal, the range is different. Yeah, okay, range inclusive is different, so. So that was mismatch type. What do you mean mismatch type? Okay, very confusing. So then we return self.last a plus. So if that b runs out, don't we want to like get our next a? So like if we get to here, if you have an next b, and then we say if let sum a equals self dot a dot next. So basically, if you can pull a b, then we'll use last a, and then we say last a equals a, b equals when plus no self dot b equals, because we just showed that b didn't pull anything, is negative a dot absolute dot to len plus 1. I want to say, and then no, don't get the next b, then so we want to say something like this and say, hey, you then return a dimension, some dimension you remove. Okay, no, and then so you would then be dimensions, which is self.len, and since we know that you're 2, we have an array that is last b and a. It's also as I8 apparently. Right. So we pass in those two, which is the last A that we used and the current B. And then we say the last A is set to that A, then this is set to this, and then so we would say that self dot B, I know, we would then return some dimension A. No, stop trying to unwrap fucking B. Return A and A plus 1 as I8. Now, what we need to do is make sure that when we initialize A, we make sure that A is always 1 less than the dimension size. Or is the dimension size, I guess. Because then, yeah, B gets to big, okay. And then else done and self equals done and return true. If we try to grab the next A and it's missing, then we just say we're done and we return true. Okay. So then we say so that should work. So when we say new, we're passing the number of dimensions. We say bishop move iterator. We say A is negative dimensions as I size. 2 dimensions as I size. Right, and then B is negative dimensions. So I think you're also +1. I don't know why you're wrapping this in so many parentheses. So, because technically we don't grab the first A until after, and then so you'll, yep, okay, and then so we want to say len is dimensions, and then last A is last underscore A is just negative dimensions as I size, and done is false. You do that first. So dimensions, and then gen moveset. So I don't think gen moveset's a thing anymore. Right. So maybe. I mean, apparently none of these are actually required. We can just get rid of all of them and just let it fall through, because each particular set is its own set of things. So all right, so we do kind of need to test it, but the idea now is if we go back to pieces and we go back to here and we say hey, next, so we would want to then, instead of saying for next in this, I guess we just turn that back on, because that does exactly the same thing, isn't it? It iterates through all directions that a bishop can move and checks each one of them. So in theory, now when we click it, it's probably just not going to work, because, you know, I did just program it. So I wish I didn't write such terrible code, but so this would let us do all two-dimensional. Yep, something like that. So attempted to subtract with overflow. So we did a lot of them. So dimension step started at -5, -4. And we're -5, -4, -5, -4, -5, -4. 3, 3, 2, 1, 1. And so we got to 0. Right, and we need to make sure we skip 0. I forgot about that. So that was in the, so that was A. A didn't get decrement B. So we need to go back to our bishop, and we need to go, and we'll do it in our primitive. No, it's in our bishop. In our bishop, we need to say, hey, when you grab B, if B equals 0, um, let b equal, I want to say it's 1, and self dot b dot next. Right, and I think A probably wants to do the same. Is oh no, not let. I'm gonna say maybe like, is it mute? I'm gonna say b equals 1. We say if a equals 0, self dot x next. Okay, so basically if it's 0, skip it and do the next one. Okay, where can you move? Apparently nowhere. Where the hell did we get to this time? So we go to negative, 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 we get to 4. Now, where the hell did you try and do? What did you try and do? Self-validate key. So you failed to validate key because you tried to pass in 5 and 5. Right. So you started at negative 5. Negative 5, 4. You went all the way around to negative 5, 4. So you shouldn't go all the way around to 5, 5. I think that's the conclusion here, is we shouldn't go from dart to dart. We should go from negative dart to positive dart. Because again, like, we're going to try all the negatives, all the positives. I think that should work. So we just need to go to the bishop. I'm going to go to here and go, hey, so when you reassign B, don't assign length, just assign let n equal the absolute of A, and then we say negative n to, wait, accuracy, yeah, okay. I want to say it's still n plus 1 because we still need to get to the number, but if you start at 5 and then reiterate, oh no, you reiterate to 5, so it would be 10. So this one's still going to crash because we, oh, that's a lot of, yeah, because we're still iterating the final one, which is that they're both the same. So we want to go from negative n to n because we don't want to check. We also, I think we need to increment by 1, don't we? Because I know you, yeah, because you're still allowing for it made it a lot further. So negative 4, and then we get to 5, 5, 4. So first off, you are plus other way, minus 1. You're n minus 1 because you're negative n. So hence the negative dimension plus 1. You also, I think, shouldn't be doing that. So if it still crashes, I reckon what's happening is it's probably this one here. So you shouldn't be checking all the way to the end like that. Okay, so you're still getting to here, and then you're still doing what? You're just, yeah, so you're failing to validate the key because the next dimension that you get is negative 5, 5. How are you still getting 5? Print line. Because you're passing in A and A plus 1, which is negative 5. Well, that's just wrong, isn't it? We should be re-evaluating B. Re-evaluating B, and then probably calling because it shouldn't be able to do it more than recursively once. We should probably just say n minus 1 and then call self dot next. Right. Because the other one had the issue of like we needed to recursively call it hundreds of times to avoid collisions, whereas this one it's like no more than like once should it ever. It's only when you update the value that it needs to avoid the collision. No, still getting fucking stuck. Something somewhere is incrementing. Who the hell is letting your... So it's got to be that this is going up to... So first off, I don't think we're finishing our first loop. Like we never increment A successfully. We could have incremented it this time, got to here, and then got to there. So let's print line inc A. I want to see if we're ever incrementing A, because if we're never incrementing A, it means it's before it even gets to the end of this that we're somehow B is getting set too high. Okay, so we increment A and then we crash. So when we increment A, so that means it's actually not this that's crashing, it's when it's 4. So we're setting you to, so it's when it's 4 and then somehow you're getting 4 as your first number. It's N is the absolute of A. Okay, so I need you to come down here. We need to say, hey, what is A, and B? What? No. You don't know B at this point, do you? Sure. No. So nope, check it, run it, please. So the hell's going on? Why is this doing what it's doing? So somehow it's getting to 4, and then for some reason when we pull 4, we're pulling the next 4. Like it immediately the next value is 4, and it's like no, and crashes. So why are you pulling 4? What is the range that B is set for? Apparently B is set from -6 to 6. A is -6. So A is going the wrong direction, which is even more confusing, considering. Oh, because A has the same problem where it's not negative by +1, which means that it's starting at -6, which is concerning. Right, because I'm specifying. I started when I make a new one, that last A is dimension -5. And then I want the next one to be 4. Right, which instead it was going to 6. Okay, did we make it further? We did, we said, so we go to 2, we go to -2, 1, and then you said you don't like this because -1 with a B of 0 to 1. So, I mean, A was -1. And B was 0 to 1. Which means B should have returned 0. So first off, when we fail validate key, can we like print what the key was going to do? Go away. I don't like that it keeps yelling at me for not formatting shit in the inline. Yeah. Don't do that. Okay. What the hell did you think it did? So -1, 1. it goes, hey, that's not a valid key, and does it. So what we need to do is work out where our bishop. So basically, when we get to here, we say, hey, if A is equal to 0, so A starts at -5 and goes all the way up to -1. So what we need to do is basically just, if A is -1, B needs to be not be 1. The question is A being 1 valid? Not really. We're basically saying that B needs to always be smaller than A, so A is 1. So we're going to say that if A equals to -1, we're going to say that A, just skip the next 3. I don't know if that's what's actually, if that'll actually fix it, because we're getting to here and we're like assigning B, so I don't think we actually got to the right spot yet. So it's said A, and then it's like, hey, A from 0 to 1, so that's A minus 1. So what's going on? But what's happening is that when A becomes -1, it's no longer possible for B to be a smaller dimension than A. So what we could do is do something like that, because B always needs to be a smaller dimension than A, then we just like skip. I don't think it's going to help exactly. Like, so when we say A is equal to 2, so when A becomes -1, we just skip past a negative to 2, and then everything else should work from there, because now it's going to go from 2 to 1. I don't know if that's actually correct. See, because you should be able to move diagonally and more than, well, that seems to be straight up. I don't think that's correct. Forward 1, up 1. Oh no, that would be correct. Forward 1, up 1. Okay. Forward 1, up 1. 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 Okay. Ironically, you stay in the same place as you move forward and up 1. Somehow you can end up over here. You can end up over there. Is it? Ooh, you can actually end up taking one of their pawns, which I don't think I like, because that's like literally like. That implies that if we swap to the white equivalent, so if we grab you, outside of the fact that there's a bunch of pawns in the way, I guess maybe. Oh. The fact that you can just take, you can actually reach their king in like a move. I don't know where it is though. So you can take their bishop, which means here you can take their pawn. So you can't do this because whatever's causing you to be able to get to there. What even are you moving through? So you're moving 1, but you're not moving through the other. Like that's moving 1. Oh, so you're moving 1 through this dimension and 1 through this dimension. 1, 1. Okay. And then because of that, you're able to get to their bishop. Pawn. But again, you need to move the pawn out of your way. No, I assume it's the pawn directly in front of you. No, it'd be this pawn. So it would be this pawn. If we can get this pawn out of the way, I think you can immediately jump on their pawn. So let's just move a random black piece and then go, hey, like any chance that you can now move. You can move to here, and 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 you can just take their pawn, and then the king can take you. Right. Well, I mean, it's better than it was, but I still don't know if this is right. I guess that the real trick here is, well, one, get rid of all the print lines that I've got, because they really clog up the ability to read what's going on in the console. So find print line. So like, is this correct? Like that's where bishop could move. Yep. Okay. So the trick would be to go, hey, move you to like here, and then so we have to move you out so that we can get you. Okay. Then I need to move you out so that I can move you out. Be like, can you actually move where you would expect to be able to move? Yes. Okay. I think it's working. Now the trick is, do we give them even more movement? Oh, it's white's turn, isn't it? So move white to here, and then you're going to move to there. Okay, so yeah, I was considering giving them even more movement, but maybe not, because I think what you could do is give them bishop. You can make them better moving more than just that axis as well. So what we can do now is we could go, where's that queen? So pieces, and then we go, okay, so this other bishop can move now. And then we go knight, and we go queen, so we go, hey, rook-like movement. And then we go, hey, bishop-like movement. Oh, apparently I've already given the queen bishop-like movement, because I literally called it bishop-like movement. He's the same iterator. So the queen can make a queen's move. Does it make him mobile elsewhere? Not really. If anything, it's made her less mobile because she's lost that ability to move into other planes. But that does mean that it shouldn't be too hard to go here and say, no, you want like a mod queen. Mod queen. Alright, so we're going to create that module. And then we want to go, hey, queen iterator. Now the issue with the queen iterator, the queen no, put that back. The queen iterator is going to run into the issue of it's going to need to be different types of iterators, and different types of iterators translates to, it's going to be a little bit weird. So we need to be like, so first off, pub struct queen move iterator. Right. So this is just gonna have nothing for now because I don't really know what it needs to hold. So then it's going to have we have to have like a pub in queen move set, right? Which is going to be a rook, which is going to be, I think you're just a dimension iterator, aren't you? Dimension iterator with a distance of 7, and then a bishop, which is a diagonal iterator of, no, diagonal
what the fuck? Super primitive diagonal iterator with 2 dimensions, and then n bishop, which is a the distance of 7. Now the issue with an n-dimensional one is that you would need to be so this would be like a I think you need to be like a reference to a a boxed dyn iterator of type of item super no of our position. Right, so then the way you're going to work is we're going to say something like well, first we're going to import iterator for queen move iterator, and type is going to item is going to equal a queen move set. Then yeah, just return none for now, thank you. So you will need to be like stage, which is going to be use size. So I guess dimensions, I don't know. And then maybe child, which is going to be a queen move iterator. Right. So when we say next on you, has infinite size. How do you have infinite size? Oh no, because it's yourself. No, a queen move set. No, this will be set, I guess. So the way it's going to work is you're going to go first of all, we'll import iterator for queen move set. Right, we're going to say if let some move right. I guess you don't need this, do you? I was going to make it do a thing, but no, you will return a set. So then each of those iterates for each of those. So we're going to say, hey, when you're new, you're just going to return. So we're going to match stage and I guess technically we should make a rook move thing first, so like mod rook, create that, then be like pub use rook move iterator, and then go rook and go pub struct rook move iterator, and then that one is just as simple as dimension, which is use size, and then how did it work? I think you just return a dimension iterator. Go my rook move and go hello rook. How does the rook move work? So the rook move just makes one of these. So you need a up, down, then. Alright, so this is what a rook is. Just makes one of these. So rook, and then so it's up. And then we get simple, well, rook move, and then we have like a new thing, but we're going to go import iterator. Dimension iterator 7, and so we say if up, you return. So the dimension iterator 7 new with a position of dimension, an axis of self dot dimension. Okay, and then up. So if up was true, I guess you just return true, up becomes false, and then if up was false, you return false, and then your self dot dimension as well. I want to say it was a dimension iterator. Right. So then we need to go, hey, dimension. So do that, and then we say, hey, you start at so then we see something like if dimension, if self dot dimension equals 0, return, and then so your dimension minus 1, and then you're also dimension minus 1, and then your result is so we're going to start with up. So you run, we set it to false, then you run, and then we set it to I guess technically you don't get to do the dimension minus 1, so then you say self dot dimension minus 1 minus equals 1. So then that should set that, and then that should set that, and then we can go, hey queen, can you just do, and again, because we're not using the queen self dot stage. Can we just do this? And also just comment this out because it's going to yell at me. Okay, so this should work, and then in theory, if this is set up correctly, we should be able to go back to our pieces, and we should be able to go, hey rook. I'm just going to comment this out. Well, not this. Wow. Okay, rook. I'm going to take this section here. We're just going to copy that section. We're going to go, hey, can we like comment out all of the rook stuff? Well, stop shifting it. Stop. I said, what? No. Okay. I have undone too far now. What the fuck did I do? Okay. Rook. All of the rook goes. Comment away. Go. Right. So do that, do that, do that. We go, okay. So then we want to say for next in rook move iterator new dimensions. We want to paste in that. I think that was correct, to be honest. Here we're going to paste it. Yep. Okay. So if we can go test the rook and it still works, that implies that the rook iterator is correct, and then we can go replace the queen bit down here with the rook iterator, and then so we can go, hey rook, or anything like that at all. So assertion failed, dimensions are less than dimensions. So it really doesn't like that. So what is doing that? Dimensions less than dimensions. So you pass in dimensions minus 1. Aha. Right, so you need current. then say current is 0, and then we say dimensions is less than current self.current, and then we say, hey, dimension is current, and then self.current, and then we want to say self.current minus equals 1 plus 1, except it would be plus 1 plus equals 1 and then minus 1, just bring it back into the line. Okay, so doing that should fix it because we kind of needed to track both. Okay, if I click rook, nope, still doesn't like it because at some point dimensions is dimensions. So what do you mean? So at some point we pass in current. Don't do it if it's equal, because it's 5 dimensions, and so if you are on dimension 5, don't do it. Okay, well, our rook looks correct now. Right, our rook can move through everything, which means that we can direct, like, maybe a queen, you know. This is, like, unnecessary because the queen is, you know, going to be replaced anyway, but we're going to say, pretty sure she does exactly the same stuff. So we just get rid of this bit. Get rid of this bit and say, instead of doing this, say, next dot with offset position, and then we say for next in 0 dot 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 dimensions is a rook movement in dimensions. So that should give the queen the rook movement and then also the bishop movement. So next to the queen, work out the queen movement. Okay, so we need to match stage, which is the first stage of the queen, which is 0, is to return. So you're going to say first off, yeah, self.stage plus 1, and then you return sum, which is a queen moveset rook with dimension it of 7 new ink true. Mismatch type. I don't get why it's a mismatch type, but anyway. So then you're going to return. Okay, let's make it return. Return. Okay, so then they both return that. And so we're going to say, okay, so this is stage 1, stage 2. And then stage n. Okay, if n equals self dot, if n is greater than or equal to self dot dimensions, return none. So this is my it's finished state. Then what we're going to do is we're going to stage plus equals. So then we go return rook. No, it's not a rook. Return some queen moveset, not a bishop. N bishop. So we need to work out how we're going to encode an n bishop move. So I think dimension it. So can we say something like fn n diagonal theta, which is going to return a boxed, that's an L move. What the fuck are you doing? Okay, dimensions, axes. Then we need to match okay, so we need to say like axes, and then we need to say, so 0 to 2, I would like this to panic
0, 2 are not used for n-dimensional diagonals. Okay, first off, that's what? No. 3. So you need to return dimensional address. Ironically, you should return a rook.
It's only 5 minutes away.
Interesting. So my concern with you is that, like, first off, stage 1, you would need to be a rook, but itters, which is a different enum, hub enum queen move itters, which is going to be a rook move itter, and this is the bishop move itter, and then this would be a I don't know, a dine itter that returns itters items of position. That seems weird. Queen move itters, something like that, and then we say, hey, so match stage. We say, hey, if you're in stage 0, if let thumb rook equals, I don't even really need the stage then, do I? So can we just say, like, match this is self dot itters, something like that, and we say, hey, if you return a rook itter, then can we say, like, next, which is then some queen itter move set this else self dot next, right? So I don't know why this isn't working. So then if you get a bishop, you say bishop and you grab the bishop, next bishop, else if self dot dimensions is greater than 2. Then we need to just say, like, a queen move itters and then none, and then obviously none just returns none. So why are you not all returning the same type? So question, I go to you and said to do. First off, you also just need to, like, fall through, and then same with you, we just need to comment you out and say to do, and go, why the hell, what type are you returning? Let t equal, what is this type? Option queen move set, and you return an option queen move set. Okay, that is correct. Now when I turn you back on, I'll turn you on, why do you not work? Maybe you do. Wait, what? If self, okay. So you need to be in an n-dimensional array, right? And so this is just going to be a to-do, so that you stop complaining. Same with you, it's just to-do. Right. And you're also just going to be a to-do. Right. So you would do that, which then this is supposed to return a boxed iterator that returns iterators that iterate position.
Okay, strange. But anyway, this should run fine. So then it's saying that I can collapse this. Okay, so what you're saying is if thumb next, then return that. Else, if self dot dimension is greater than 2, else self dot iters equals none. Right. And then you'd be the same, where you're going to go, hey, and then we're also going to say that when you get to here that self dot stage was 3. Right. So then we're going to say if sum next. Dynamo position sum. Okay, else none. So what is your issue? Okay, first off, you probably want to return boxed diameters, like so that, you know, we can box them up. So then we don't need to box you, we can just say that you're next. And then to this, right, and then we need to go up here and say, actually, you return boxed diameters. So, okay, no, I feel like that's wrong because it needs to be like if let sum next iter next, then return that, else self dot else if self dot dimensions is greater than self dot stage plus equals 1, iters plus equals stage, dimensions next. None. Okay, and then in here we can work out how to do an n-dimensional thing. So my thinking is that we can go like box primitive super diagonal iter 3. See, the issue is that you take 2 arguments because you need a key, and the key for you would be key. Your key would be 1, 2, 3, I believe. Now, matching armors. So the issue is that you're a diagonal iterator. So 4, and then 5, and then 6, and I'm gonna only go to 7, and then I guess this would just be like a not underscore not implemented. Implement unimplemented. Not yet. Okay. See, that's the issue, is that this is apparently a different type. Because well, first off, you're apparently not the right type. Because first off, you should be returning, you're supposed to be a boxed iterator whose item is boxed iterators. So we can work on it, but that's the idea, is that like each diagonal iterator will each time it'll grab a different iterator that generates iterators and can then generate those. But anyway, I gotta go have dinner. Been fun making this weird monstrosity. I will see you all next time. Thank you for tuning in.